Good evening. Welcome for today's session. If my audio and video is clear, I request the students to just raise the hand so that we can start our session for today. If audio and video is clear, I request the students to please raise the hand so that we can start our session for today. Okay, right. Just let us revise the topic that we have discussed yesterday and let us continue for today's topic. So in the yesterday's class, first I have defined what do you mean by power system. So if you observe the power system network, it consists of power generation, transmission, distribution, and utilization. So it is nothing but a system which deals with the principles of generation, transmission, distribution, and utilization. So we have a generation network, transmission network, distribution network, and load utilization. Okay. So why we need a power system protection? What our topic is power system protection. So why we need a power system protection here? So the network is experiencing faults, mainly two types of faults. One is open circuit and the other one is short circuit faults. Okay. So in yesterday's class we have discussed about this open circuit fault and short circuit fault. Open circuit fault means what? It is also known as a series fault. Why the open circuit fault may be? It may be due to unwanted, that is unnecessary melting of fuse or opening of circuit breaker contacts or opening of jumper contacts. That may be a reason for open circuit fault. So during normal condition, the network is operated under balanced state. Balanced state means what? All the voltage and currents are equally magnitude and phase displaced by how much? 120 degrees. Then the network is said to be in balanced mode of operation for a three-phase system. So now let us consider case one, melting of fuse in any one of the phase. Suppose if the fuse gets melted in any one of the phase, that will create an unbalance in the system and it is treated as open circuit fault. If the fuse melts in any of the two phases, then also it will create an unbalanced operation. It is treated as an open circuit fault. Okay. If the fuse melts in all the three phases, then the alternator will go to no load operation. So it is not treated as a fault. Okay. It is not a fault. Now, what is the consequence of open circuit fault we have analyzed? So, whatever the initially before fault, whatever the mechanical input that has been provided is converted into electrical power output and delivered to load. So, initially the net power is zero. So, the machine is neither accelerated nor deaccelerated. So, the speed at which it is running is synchronous speed. Frequency is rated frequency. Voltages and currents that are existing in the network are within the specified limits. Okay, the voltage and currents that are existing in the network are within the specified limits. Okay, but whenever you consider an open circuit fault, suppose R phase got opened, IR equal to 0, then mechanical input is same, but the electrical power transfer has been reduced. P electrical get reduced. So the net electrical power is not equal to 0, it is positive. So the machine will experience what? Acceleration. The machine will experience acceleration. So omega is greater than omega s. Frequency increases, voltage increases. So what is the consequence of open circuit fault? Mainly the open circuit fault will result in what? Over voltage. Open circuit fault will result in over voltage. So what happens if the over voltage takes place? It may lead to failure of insulation. So we have seen any electrical equipment can be analyzed in terms of two aspects. One is conductor and insulation. So the size of the conductor is decided by its area, current carrying capacity, and thickness of insulation is based on the operating voltage. So whenever there is over voltage experience, it may lead to damage of insulation. So what about short circuit fault? It is also known as what? Shunt fault. What are the reasons for occurrence of short circuit fault? We have seen what are the reasons for occurrence of a short circuit fault. Failure of insulation, falling of tree branches, collapsing of supporting towers, birds or snakes, bridging the gap between conductor and cross arm. Between these two, there is an insulator here. There is an insulator. This bird is directly bypassing that insulator, so it will create a short circuit fault. Snatching of power conductor. What are the different types of short circuit faults that we have analyzed in the yesterday's class? What are the different types of short circuit faults? Line to ground. If any one of the phase is short circuited to ground, then it is treated as line to ground. Line to line. If any of the two phases are short circuited, then it is treated as line to line fault. Double line to ground. If any of the two phases short circuited to ground, that is treated as double line to ground fault. Triple line to ground. Triple line means all the three phases are short circuited, then it is triple line. If all the three phases are short circuited to ground, that is treated as triple line to ground fault. So what is the consequence of short circuit fault? What happens if short circuit fault takes place? That we have analyzed. So normal condition, the current is 0.099 ampere. But whenever you consider a short circuit, the short circuit current is approximately here 10 amperes. So what is the observation? Short circuit will result in overcurrents and decrement in speed, frequency and voltage. Power factor also decreases. So it is resulting in overcurrent. So what happens if overcurrent takes place? The network may experience two types of stresses. One is thermal stress and the other one is what? Mechanical stress. Thermal stress means what? Excessive heat generation may lead to melting of conductor, breaking of conductor, overheating of insulation. Okay. Mechanical stress. Mechanical stress, the force experienced due to short circuit condition will be very high when compared to force during normal condition between two current carrying conductors. Okay. So due to this, the conductor may get dislocated from its original position. Okay, due to mechanical stress. So what is our observation? Either it may be an open circuit fault or short circuit fault. It is damaging the electrical equipment. It is damaging the electrical equipment. To avoid that, we need protection system. So we need to sense these quantities by using voltage and sorry by using a relays, and isolation is to be done. That is, faulty section and healthy section are to be isolated by using a circuit breaker. Okay. So relay. What do you mean by relay? It is nothing but a sensing device which continuously monitors the assigned quantity. If at any point of time the assigned quantity exceeds its set value, it will initiate the action of circuit breaker to isolate the faulty section and healthy section. Okay. So we have seen how the relay and the circuit breaker are configured in the system. How the relay and the circuit breaker will be configured in the system. We have visualized in the last class with an animation also. Okay. So and we have discussed about the instrument transformer uses, and we have discussed when the relay will operate also. Okay. What are the advantages of instrument transformers? It will step down the voltage and current magnitudes so that the design of relay will be easier. It will isolate the protection circuit and live circuit. So we have seen by taking an example of CT. So when the relay will be operated, whenever the current seen by the relay is more than its set value. Okay. So current transformers, mainly CTs are of two types: measuring CT and protection CT. So measuring CT, on the secondary side of the CT, what will be connected? In case of measuring CT, on the secondary side of the CT, ammeter or current coil of wattmeter or current coil of energy meter will be connected. They are used for only measurement purpose. If the fault current is reflected on secondary side, this metering equipment may get damaged. So the design criteria is different. So measuring CT is designed to operate at saturation point. Protection CT is designed to operate at angle point. Volume of the CT core required will be more for protection CT because it should carry the fault current also without any saturation. So the volume of the CT core required will be more for protection CT when compared to measuring CT. Okay. So PTs are generally configured in phase manner. PTs will step down the voltage magnitude. So we have after that we have gone through what do you mean by relay time, circuit breaker time, and fault clearing time. So the time lapse from the instant of fault to the instant of issuing the trip signal is nothing but relay time. Circuit breaker time means from the instant of issuing the trip signal to the instant of arc quenching is nothing but circuit breaker time. So circuit breaker time is classified as sum of opening time of the contacts and arc quenching time because whenever the contacts are separated, the arc formation takes place. Fault clearing time it is nothing but this, from the time lapse from the instant of fault to instant of arc quenching. It is a sum of relay time and circuit breaker time. Then we have gone through relay characteristics. We have gone through relay characteristics. First one is speed of operation. Relay should operate at high speed so that the relay time of operation will be less. So if the time of operation is less, what happens? The fault clearing time will be less. System is more stable. Okay. Then we have seen about selectivity. Selectivity here can be analyzed in terms of two aspects. One is unit selectivity and the other one is non-unit selectivity. Unit selectivity means what? It should operate only for the faults within its zone. Non-unit selectivity means it may operate for the faults within its zone as well as outside its zone. If it is operating only for the faults within its zone, it is unit selectivity. If it is operating for the faults outside its zone, it is non-unit selectivity. I have given the example for unit selectivity as well as non-unit selectivity. Unit selectivity means what? Differential relay is the example for unit selectivity. Non-unit selectivity example is what? Distance protection. Sensitivity. Next characteristic is sensitivity. It is sensitivity should be very high. What happens if sensitivity is high? Relay can sense even very small changes in the operating quantities. Okay. How do you express the sensitivity? And that we have discussed in the last class in terms of volt ampere rating. Okay. The relay which is having least volt ampere rating will be highly sensitive. Okay. Reliability. Reliability should be high. It should give 100% assurance for correct operation. Okay, it should be giving the 100% assurance for correct operation. Dependability. It should operate whenever it is required to operate. Security means it should not operate whenever it is not required to operate. Even though it is observing the fault, whenever it is not required, it should not operate. Okay. So we have gone through classification of relays based on time of operation in the last class. We have gone through the classification of relays based on time of operation. So first one is instantaneous relay. First one is what? Instantaneous relay. Instantaneous relay means the name itself says it is of instantaneous operation. It is of what operation? Instantaneous operation. There will be no intentional time delay introduced into the relay circuit. We will not intentionally introduce any time delay. We will not intentionally introduce any time delay into the relay circuit. It should operate within zero time, but practically operating within zero time is difficult. It is not possible. So if the time of operation is less than or equal to zero point 0.1 second, then it is treated as instantaneous relay. Okay. The time here, if you observe the characteristic, the time of operation is independent of what? Fault current magnitude in case of this instantaneous type relays. Next, we have gone through definite time relays. In this relays, intentional time delay is provided by the user, okay, into the relay circuit. So relay will operate only after certain number of cycles, even though it is seeing the current more than its pickup current. So time of operation is independent of fault current magnitude. Here also the time of operation is independent of fault current magnitude. Inverse time relay. In this relay, the time of operation is inversely proportional to what? Fault current magnitude. Here the time of operation depends on what? Fault current magnitude in case of inverse time relays. Okay. So if the fault current magnitude is very high, then the time of operation is less. So if you compare triple line fault with the line to ground fault, triple line fault will be cleared fast. That means relay will operate fast in case of triple line fault because the fault current in triple line will be more when compared to LG fault. Next, we have gone through inverse definite minimum time relay, IDMT relay. Inverse definite minimum time relay. So here IDMT relay stands for inverse definite minimum time. Here it has both inverse as well as definite time characteristics. From pickup current to saturation current, it will act as inverse relay. From saturation beyond saturation point, it will act as definite time relay. Okay. So here definite time operation. How do you achieve definite time operation? By considering the saturation of CT core. By considering the saturation of CT core, we will get the definite time operation. Okay. This was the topic that we have discussed in the last class. Okay. Now let us go for today's session. Now let us start our discussion for today. Now let us somebody are asking regarding the uploading of material of yesterday's class. I've already informed the concerned staff. I think they will be uploading today. Yeah, that is not an issue. They will be uploading today. Now they will be uploading your notes today, sir. No issue. I will ask them to upload. Now let us start. How we can get multiple pickup values? How you can get multiple pickup values? Or how can we change the pickup value of a relay? Suppose if you have purchased a 5 ampere relay, how can we change the pickup current of that relay? That is the question. Okay. How can we get adjust the pickup value of relay? How can we adjust the pickup value of a relay? That is the question. So how can we adjust the pickup value of a relay? So suppose if you have purchased 5 ampere relay, the pickup setting of that relay is 5 amperes only, or we can adjust as per our requirement. You can adjust to 4 amperes or 5.5 amperes or 6 amperes. Is there any chance of adjusting the pickup current? Yes. So now let us observe here. Suppose if you consider the relay coil, this is what relay coil. So on the relay coil, there will be plug setting arrangement. On the relay coil, there will be what? Plug setting arrangement. So there will be a plug point, plug setting arrangement. So whenever you change the plug position, automatically the number of turns that are connected will be changed. The number of turns that are connected will be changing whenever you change the plug point. Okay. So what happens if you change the number of turns? My question is, how can you adjust the pickup value of the relay? My answer is, by changing the number of turns on the relay coil, we can get multiple pickup values. Okay. I will prove that by changing the number of turns, by changing the number of turns on relay coil, on relay coil, we can get multiple pickup values. Pickup value means what? The quantity above which the relay is expected to operate. Suppose if your pickup value is 4 amperes, if the relay observes the current beyond 4 amperes, the relay will operate. Pickup value means the quantity above which the relay is expected to operate, is nothing but pickup value. We will define that later. Okay. So how you are getting the different pickup values? By changing the number of turns on the relay coil. Okay. Understood my point? Now, so what happens if the number of turns are changed? If the number of turns are changed, what happens? Now let us see. Operating torque, operating operating torque, operating torque, TOP. How can you write? It is directly proportional to what? Flux into current. Operating torque is directly proportional to flux into current. How do you establish the relation for flux? Flux is what? MMF divided by reluctance. MMF divided by what? Reluctance. So flux is directly proportional to what? MMF. Flux is directly proportional to MMF. So here MMF is what? Number of turns into current. Number of turns into current. Now we can write the operating torque. We can write the operating torque TOP as it is directly proportional to flux into current. Flux is directly proportional to number of turns into current. TOP is directly proportional to number of turns into current into current. So operating torque directly proportional to N into I square. N into I square. Okay. Here for a constant operating torque. Now observe here. For a constant operating torque. For a constant operating torque. Operating torque. For a constant operating torque. What about the relation here? Current is inversely proportional to square root of n. Current is inversely proportional to square root of n. I is inversely proportional to what? Square root of n. Now, what is your observation here? If you increase the number of turns, if you increase the number of turns, pickup current reduces. If you increase the number of turns, pickup current reduces. And if you decrease the number of turns, pickup current increases. To decrease the number of turns, pickup current increases. That means from this relation, can we say that whenever you are changing the number of turns on the relay coil, the pickup current changes or not? Yes or no? By changing the number of turns on the relay coil, the pickup current changes. Okay. So, so how can we get? By changing the number of turns on the relay coil, we can get multiple pickup values. Multiple pickup values. Here, how can we calculate the plug setting multiplier of the relay? Here, the important calculation in this relays is where the numericals are asked frequently is how do you calculate the plug setting multiplier of the relay? Okay, calculation of plug setting multiplier, which is also known as PSM. Plug setting multiplier. Plug setting multiplier, which is also known as what? PSM. Plug setting multiplier, or it is also known as PSM. So how do you calculate the plug setting multiplier, sir? Any idea? Plug setting multiplier of the relay? PSM is equal to fault current on primary side, fault current on primary side by CT ratio, CT ratio, fault current on primary side by CT ratio into relay pickup value, relay pickup value. Okay, fault current on primary side by CT ratio into relay pickup value gives the plug setting multiplier of the relay. So here, what do you mean by relay pickup value? How can we define relay pickup value? Relay pickup value. How can you define relay pickup value? What do you mean by relay pickup value? Relay pickup value means what? Relay pickup value means the quantity above which the relay is expected to operate. The quantity above which the relay is expected to operate is known as relay pickup value. Relay pickup value. Relay pickup value means what? The quantity above which relay is expected to operate is known as relay pickup value. Suppose if your relay pickup value is 5 amperes, above 5 amperes, if the relay sees the current, then the relay will operate. That is the meaning of relay pickup value. Okay. Now, just a minute. Okay, right. See here. Now let us take an example and try to calculate the plug setting multiplier of the relay. How do you calculate the relay pickup value? So what is the relation for relay pickup value? It is the quantity above which relay is expected to operate. So how do you calculate relay pickup value? The relay pickup value, how do you calculate? It is also known as RPV, sir. Now onwards, I will say relay pickup value as RPV. Okay, relay pickup value is equal to relay setting, relay setting, relay setting multiplied with rated current of the relay, rated current of the rated current of relay, rated current of the relay. Okay, so if the rated current of the relay is not given in the question, if the rated current of the relay is not given in the question, then what we need to take? We need to take the rating of CT secondary as rated current of the relay. Because if you observe here, if this is a CT, primary of the CT is connected in series with the line. Where the relay is connected? The relay is connected to the CT secondary. Relay is connected on CT secondary. So if the rated current of the relay is not given, the rating of CT secondary is taken as rated current of the relay. If rated current of the relay, rated current of relay is not given, the rating of CT secondary, the rating of CT secondary taken is taken as relay current rating, relay rating. Okay, so we have defined what is PSM. PSM is fault current on primary side by CD ratio into relay pickup value. Relay pickup value means what? The quantity above which relay is expected to operate. How do you calculate relay pickup value? Relay setting multiplied with rated current of the relay. Okay. Now let us take a problem. Now let us try to solve one problem here. A radial distribution system. A radial distribution system. A radial distribution system is protected by, if the question is given like a radial distribution system is protected by overcurrent protection scheme, a radial distribution system is protected by what? Overcurrent protection scheme using CT with ratio 400 by 5. CT ratio is how much? 400 by 5. Relay setting is 120% of full load current. 120% of full load current. Calculate plug setting multiplier if fault current is 4800 amperes. Fault current is how much? 4800 amperes. We ask you to calculate the plug setting multiplier of the relay. Now observe this question. A radial distribution system is protected by overcurrent protection scheme using the CT ratio of 400 by 5, relay setting 120% of full load current. Calculate PSM if the fault current is how much? 4800 amperes. So how do you find the solution for this problem? How can you find the solution for this problem? So what is the relation for PSM, sir? PSM is fault current IF by CT ratio multiplied with relay pickup value RPV. RPV stands for what? Relay pickup value. So here fault current given as 4800 amperes, CT ratio given, but relay pickup value is not given. Fault current how much given? 4800 amperes given. CT ratio given as 400 by 5. CT ratio is 400 by 5 given in the question. But here relay pickup value is not given. We need to calculate what? Relay pickup value. How do you calculate relay pickup value? How do you calculate relay pickup value? Relay pickup value. That is nothing but RPV. How do you calculate, sir? A relay pickup value is equal to relay setting multiplied with the rated current of the relay. Rated current of relay. Here, relay setting given in the question as 120% of full load current. Relay setting given as what? 120% of full load current. So relay setting is 120% of full load current means 120 by 100 into rated current of the relay. Here rated current of the relay not given in the question. Rated current of the relay is not given in the question. So whenever the rated current of the relay is not given, what we need to take? Rating of CT secondary. Rating of CT secondary is taken as rated current of the relay. Okay. Rating of CT secondary is how much here? 5 amperes. So how much do you get, sir? This will get cancelled out. 5 ones are 5 twos are. How much do you get? 6 amperes. So relay pickup value is what? 6 amperes. What is the meaning of that? If relay observes the current more than 6 amperes, the relay is expected to operate. Okay. If the relay observes the current more than 6 amperes, the relay is expected to operate. Now let us calculate plug setting multiplier. Plug setting multiplier is equal to fault current is how much? 4800. 4800. CT ratio is 400 by 5 into relay pickup value is 6 amperes. Okay. Now how much do you get? So if you simplify this, can anyone simplify this and can anyone simplify this and post the answer, sir? And post the answer. PSM calculate. Anyone calculate and post the answer? PSM is how much? 10. Okay. PSM is 10. So we got the plug setting multiplier of the relay as how much? 10. Okay. So now let us take one more problem. Let us take one more problem. So if the question is given like a radial a radial distribution system is protected by overcurrent relay, overcurrent protection scheme, overcurrent protection scheme using CT ratio 200 by 1, CT ratio 200 by 1, and relay setting is 140% of full load current. 140% of full load current. Calculate fault current. Calculate fault current if PSM is 8. If plug setting multiplier is 8, what is asking to calculate? The fault current. Here what is asking, or they are asking to calculate fault current. So what is given? A radial distribution system is protected by overcurrent protection scheme using the CT with ratio 200 by 1. Here how do you solve, sir? CT ratio. CT ratio. CT ratio given 200 by 1. PSM given as 8. So how do you calculate relay pickup value? Relay pickup value is equal to relay setting multiplied with the rated current of the relay. Rated current of the relay. Here rated current of the relay is not given. By default, the rating of CT secondary will be the rated current of the relay. So relay setting is how much? 140%, 140 by 100 into rated current of the relay is 1 ampere, CT secondary current. Okay. So here it is how much? 1.4 amperes. This will get cancelled 1.4 amperes. Now how do you calculate the PSM? PSM formula is what? PSM relation is what here? PSM is equal to fault current by CT ratio, fault current by CT ratio into relay pickup value. PSM is what here? PSM is 8. We need to calculate the fault current. CT ratio is 200 by 1. Relay pickup value calculated is how much? 1.4. 1.4. So IF is equal to what? Fault current is 8 into 200 into 1.4. So if you simplify this, you get the fault current. Can anyone post the answer? Fault current. Can anyone calculate and post the answer, sir? So fault current is how much? 2240. 2240 amperes. 2240 amperes. Okay. So now how I have calculated how I have calculated the value of PSM here. PSM is equal to fault current on primary side, fault current on primary side by CT ratio, fault current on primary side by CT ratio into relay pickup value. So now observe here, if the CT ratio here, CT ratio given as 400 by 5. CT ratio is how much? 400 by 5. So relay is connected where? Relay is connected on CT secondary side. Relay is connected on CT secondary side. Suppose here, if the fault current of 200 amperes is flowing, the current is how much? 200 amperes. What will be the current on relay side? What will be the current on relay side? 2.5 amperes. Yes or no? Half of that, 2.5 amperes. So here fault current on primary side 200 amperes by CT ratio. CT ratio is how much? 400 by 5. 400 by 5. How much do you get? 2.5 amperes. Yes or no? So what is your analysis here? Fault current on primary side by CT ratio. Fault current on primary side by CT ratio. Fault current on primary side by CT ratio. We can rewrite it as what? We can rewrite it as PSM is equal to fault current on primary side by CT ratio can be written as what? Fault current on relay side, fault current on relay side or secondary side, on secondary side by relay pickup value by a pickup value relay pickup value. Okay, so fault current on relay side is nothing but the fault current on secondary side is nothing but the fault current which is reflected on relay side. Okay, fault current which is reflected on relay side. When will this relay operates? When will the relay operate? Whenever the, or you can also write it as secondary side or relay side also, relay side. Okay, that is nothing but fault current observed by the relay by for relay pickup value. When will the relay operate? Whenever the current seen by the relay is more than the relay pickup value. That means numerator should be more or denominator should be more. When numerator is greater than the denominator, then only the relay will operate. That means here you may get PSM is equal to 1, you may get PSM greater than 1, or you may get PSM less than 1. PSM greater than 1, PSM less than 1. So when PSM is equal to 1, relay is at verge of operation. Relay is at verge of operation. Verge of operation. Relay is at verge of operation. When PSM is greater than 1, the relay will operate. The relay will operate. Yeah. Because the fault current observed by the relay will be, when it is greater than 1, it will be more than the relay pickup value. Okay, relay will operate. Relay will operate. When it is less than 1, relay will not operate. Okay, relay will not operate. Okay. Understood my point? PSM is greater than 1, the relay will operate. Is equal to 1, it is at verge of operation, that is at the boundary condition. It will be at the boundary condition. And less than 1, relay will not operate. Based on that, if you can program, if you want to program, you can program the relay. Okay. Now, for an inverse type relay, okay, inverse time relay, let us analyze. For an inverse time relay, for an inverse time relay, what is the characteristic that we got, that we have discussed in the last class? For an inverse time relay, time of operation is inversely proportional to what? Fault current. Time of operation is inversely proportional to fault current. And what about PSM here? PSM is fault current by CT ratio into CT ratio multiplied with relay pickup value. Okay. So PSM is directly proportional to what? Fault current. PSM is directly proportional to fault current. So if the fault current increases, time of operation decreases. Okay. In case of inverse time relay or inverse type relay. Here, if the fault current increases, PSM increases. PSM increases. Now, what is the relation between this time of operation and PSM here? If you observe, here the fault current is increasing, time of operation decreasing. Fault current is increasing, PSM is increasing. So what is our observation? Time of operation is inversely proportional to what? PSM. Time of operation is inversely proportional to PSM. So if you plot the characteristic for an inverse time relay, if you plot the characteristic between PSM and time of operation, what you will get? You will get inverse characteristic. What type of characteristic you will be getting? You will be getting inverse type of characteristic. Okay. So this is for what relation between PSM and time of operation in case of inverse time relay. Okay. I think you all got this. Inverse time relay, you will get this observation. So this is about the current setting. So I have started the discussion for today's class by how, considering this topic, that is how can we get pickup value of the relay, adjust the pickup value of the. How do you adjust the pickup value of the relay? That was the topic that I have considered. So how do you adjust the pickup value of the relay? How do you adjust the pickup value of the relay? How can you get multiple pickup values? By changing the number of turns on the relay coil. And we have observed, if you increase the number of turns, pickup current decreases. If you decrease the number of turns, pickup current increases. So here, a layman cannot calculate this number of turns and current, all those relations. Okay, that's why here he will indicate 100%, 50%, 25%, 35%, like that. Relay setting will be in terms of percentage. Relay setting will be in terms of percentage, because suppose if a layman has purchased the relay, he cannot do all the calculations. No, directly relay setting will be in terms of percentage. Okay. So how do you calculate the flux setting multiplier of the relay? That is nothing but the fault current on primary side by CT ratio into relay pickup value. Relay pickup value means what? The quantity above which relay is expected to operate. The quantity above which relay is expected to operate. So I have taken the problems how to calculate the PSM. Now, when will the relay operate? PSM is greater than 1, the relay will operate. PSM is equal to 1, it is at the verge of operation. PSM is less than 1, the relay will not operate. So for an inverse time relay, the observation between the time variation with PSM is inverse. Okay. Now, that is about current setting. What about time of operation? How can we get different times of operation? How can we adjust? How can we adjust different times of operation? Times of operation. How can we adjust different times of operation, sir? Any idea? How can we adjust different times of operation? First of all, you need to know. First of all, you need to know on what factors the time of operation of the relay depends. The time of operation of the relay depends on what factors. Okay, so for understanding how to get different times of operation, first you need to know on what factors the time of operation of relay depends. The time of operation of the relay, time of operation of relay mainly depends on mainly depends on two factors. Two factors. The time of operation of the relay mainly depends on what factors? Two factors. How many factors? Two factors. First one is the distance that is to be traveled by the relay contact. The distance that is to be traveled by relay contact. What factors are? The distance that is to be traveled by the relay contact. Second one is the speed at which the relay contact is moving. The speed at which relay contact relay contact is moving. So here the time of operation of the relay mainly depends on two factors, sir. One is the distance that is to be traveled by the relay contact. And the second one is the speed at which the relay contact is moving. The speed at which the relay contact is moving. Now let us see how what variation you can observe. Can we change the speed at which the relay contact is moving? The speed of moving of that relay contact depends on the fault current magnitude. Fault current magnitude is not in our hands. But what we can control, the distance that is to be traveled by the relay contact is to be controlled. Okay. Now let us observe here. Now let us take disk type relay. Now let us take disk type relay. Now let us consider a disk type relay here. Suppose if you consider a disk type relay, and at this point initially the relay contact is at rest. Here initially before fault the relay contact is at this position, and there is a backstop arrangement will be placed here. This is a backstop. This will not allow the relay contact to move beyond that, so so that it will not close the trip circuit during normal operation. So these two are the trip contacts. These two are the trip circuit contacts. During normal condition, the relay contact is placed at this position. But whenever the fault takes place, what happens? The disk will experience a force. This disk will experience a force, and this relay contact has to rotate. That means this relay contact has to move this position, and it should close the trip circuit. Understood my point here? During normal condition, the relay contact is at this position. But whenever the fault takes place, the relay contact, this disk rotates. Relay contact is to move to this distance and close the trip circuit. Okay. So let the time of operation be some t1 seconds. T1 seconds. Now let us consider the case 2. Now let us consider the second case. So in the second case, suppose in the second case, if the relay contact is initially placed at this position, by using a backstop arrangement. Now the backstop has been pushed to this point. Backstop has been pushed to this point. Now, whenever the fault takes place, this relay contact has to move this distance, and it should close the trip contacts. Initially, the relay contact has held at this position. Now, how much distance that is to be traveled? This is the distance that is to be traveled. Now, I observe this case 1 and case 2, this first case and this second case, where the distance that is to be traveled by the relay contact will be less in the second case. Okay, let the time taken by the relay to operate is t2 seconds. So here t1 is greater than t2, because here the distance that is to be traveled by the relay contact is more for the same speed. So how you are getting different times of operation? By changing the distance that is to be traveled by the relay contact. That means here we are changing the initial rest position of the relay contact. So we will have different points on that timing set arrangement disk. So based on that you will be getting. Okay. So here we can adjust, we can get different times of operation. We can get different times of operation by changing the initial by changing the distance that is to be traveled by the relay contact. Okay. So we can get different times of operation by changing the distance that is to be traveled by the relay contact with backstop position. Backstop position. Backstop means if for some doors, doors also will fit a backstop, no, so that whenever you push the door and whenever you remove that, again it will go to the initial rest position. That is nothing but a backstop position. So here you can get different types of operations by changing the distance that is to be traveled by the relay contact, that is with the help of backstop position. Okay, initial rest position is changed. Here, how do you get? How do you adjust? That means that it is in terms of what? Time setting multiplier. Current setting is in terms of flux setting multiplier. Here, what do you calculate? Time setting multiplier. Time multiplier setting. Multiplier setting or time setting multiplier. It is also known as what? Time setting multiplier, or it is also known as TMS, TSM, or TSM. Both are same. Time setting multiplier or TMS. So how do you calculate this time multiplier setting? So here, time setting multiplier is nothing but it is a ratio of actual time of operation, actual time of operation, actual time of operation of relay in seconds, actual time of operation of relay in seconds by time of operation specified by the manufacturer, time of operation, time of operation specified by the manufacturer in seconds, in seconds at PSM. At that particular PSM, what is the time of operation specified by the manufacturer in its PSM? Okay. So here, how you are getting different times of operation by changing the distance that is to be traveled by the relay contact. This is 100% distance. This is the 100% distance. For this 100% distance, the manufacturer will give the time of operation. The manufacturer will give the time of operation. Suppose this is 50% distance. That this is 50% distance. For this 50%, you can calculate. You can calculate if 100% for 100% distance. Suppose if it takes 5 seconds, for 50% of the distance that is to be traveled, it is 2.5 seconds. That 2.5 seconds will not be given by the manufacturer. He will give for complete rotation how much time it will take. For half of the distance, 30%, 40%, that you need to calculate. That you need to calculate. Okay. So what is time multiplier setting or time setting multiplier? Actual time of operation of the relay in seconds by time of operation specified by the manufacturer in seconds at that particular PSM. At that particular PSM. Okay. Now let us take one example, and from that you can analyze what is the use of this time setting multiplier. Now if the problem is given like this, problem is given like this: a radial distribution system, a radial distribution system is protected by overcurrent overcurrent protection scheme, overcurrent protection scheme using CT ratio. CT ratio is 400 by 5, 400 by 5, and relay setting, relay setting is 140% of full load current, 140% of full load current, full load current. So if the problems are given like this, first bit, he is asking to calculate pickup current of the relay. Pickup current of the relay. Okay. I'll go step by step. Pickup current of relay. How do you calculate the pickup current of the relay? So what do you mean by pickup current? What do you mean by pickup current, sir, here? What do you mean by pickup current of the relay? How do you calculate pickup current of the relay? Any idea? Pickup current of the relay means what? The quantity above which the relay is expected to operate. The quantity above which relay is expected to operate is known as what? Pickup current of the relay. The current above which the relay is expected to operate. It is nothing but relay pickup value. Pickup current of the relay is nothing but relay pickup value. Relay pickup value. It is nothing but relay pickup value. So how do you calculate relay pickup value? Relay setting multiplied with the rated current of the relay. Multiplied with rated current of relay. Rated current of the relay. So here relay setting is given as how much? Relay setting given in the question as how much? 140%. 140 by 100. Relay setting is 140%. Rated current of the relay not given. By default, what is the rated current of the relay? 5 amperes. CT secondary current. So how much, sir? Anyone calculate and post the answer? 5 into 1.4. 5 into 1.4. How much you get? How much? 7 amperes. So how much, sir? 7 amperes. So whenever the relay observes the current more than this 7 amperes, the relay is expected to operate. Okay, more than this 7 amperes, the relay is expected to operate. So now this is the first question. What is asking? The relay pickup value. Now let us go for the second bit. In B bit, if he has given like this, if the fault current is, if the fault current is 5600 amperes, 5000, if the fault current is 5600 amperes, calculate PSM, calculate plug setting multiplier of the relay. Calculate plug setting multiplier of the relay. So how do we calculate the PSM? What is the relation, sir? PSM is equal to fault current by CT ratio, fault current by CT ratio into relay pickup value, Here, the fault current is how much? 5600. CT ratio is how much? CT ratio given is 400 by 5. CT ratio is 400 by 5. Relay pickup value is how much here? Relay pickup value is 7 amperes. So if you simplify this, how much PSM you will get? Try to solve this and post the answer. PSM. PSM how much, sir? Calculate PSM and post the answer. PSM is 10. Okay. PSM is plug setting multiplier is 10. PSM will not have any units. This is a multiplier, sir. Note that. PSM will not have any units. PSM and TSM, plug setting multiplier and time setting multiplier, will not have any units. Will not have any units. Any units. Okay. It will not have any units. Now, let us go for the third question. For the third question, that is third bit of the same question. Calculate operating time of the relay, operating time of the relay, operating time of relay if time setting multiplier is 0.3. Time setting multiplier is, calculate operating time of the relay if time setting multiplier is what? 0.3, and the relay characteristic, the relay characteristic, the relay characteristic is given in the table, So he has given the relay characteristic in the form of a table here. He has specified like this. He has given the variation of PSM and time. So he has given the characteristic like this. For a PSM of 2, suppose the time of operation is some 8 seconds, and PSM of 4, the time of operation is 7.5 seconds. If the PSM is 6, time of operation is 6 seconds, 6.5 seconds. Suppose PSM is 8, time of operation is 6 seconds, and PSM of 10, if the time of operation is 5 seconds, and if the PSM of 12, it is some 4.5 seconds, like this. Here the characteristic is given in the form of a table. What is asking to calculate? Operating time of the relay. Operating TMS given as how much? 0.3. Now let us try to calculate. What is the time multiplier setting? What is the time multiplier setting? TSM. Time multiplier setting, how do you calculate? Actual time of operation of the relay. Actual time of operation of the relay. Time of operation of relay in seconds by time of operation specified by the specified by manufacturer manufacturer in seconds at that PSM. At that PSM. Time of operation specified by the manufacturer in seconds at that PSM. Now, if you observe the question, what is the time multiplier setting given, sir? 0.3. Time multiplier setting given as 0.3. 0.3. Now, here you need to calculate actual time of operation. Actual time of operation. Time of operation that you need to calculate. Operation in seconds that you need to calculate. But the time of operation here, PSM is how much? PSM is 10. So for a PSM of time, for a PSM of 10, for a PSM of 10, for a PSM of 10, what is the time given by the manufacturer? How much? 5 seconds. Okay. For a PSM of 10, here for a PSM of 10, when PSM is 10, the time given by the manufacturer is how much? 5 seconds. Okay. This is from the characteristic that you got. So now how do you calculate the actual time of operation? Actual time of operation. How do you calculate the actual time of operation? Actual time of operation. How do you calculate, sir? 0.3 into 5. How much do you get? 1.5 seconds. 1.5 seconds. So this is the procedure to calculate the actual time of operation if time multiplier setting is given. Now let us observe this question once again. So what he has given, sir, here? Now observe here. A radial distribution system is protected by overcurrent protection scheme using the CT with ratio of 400 by 5. Here CT ratio is what? 400 by 5. And the relay setting is how much? 140% of full load current. What is asking to calculate? Pickup current of the relay. So how do you calculate the pickup current of the relay? Pickup current of the relay is nothing but the quantity above which relay is expected to operate. The quantity above which relay is expected to operate is nothing but pickup current of the relay. So how do you calculate relay pickup value? Relay setting multiplied with the rated current of the relay. Here, rated current of the relay is not given in the question. By default, rating of CT secondary is taken as rated current of the relay. So how much you get? 7 amperes. Now in the second bit, what he has given in the second question, what he has given is the fault current is 5600 amperes. If the fault current is 5600 amperes, what is the plug setting multiplier of the relay? So PSM is what? Fault current by CT ratio into relay pickup value. So all the values are known. PSM is 10. PSM and TSM will not have any units. Plug setting multiplier and time setting multiplier will not have any units. Now next, what are you asking? Calculate the operating time of the relay if TMS is 0.3 and relay characteristic is given in the form of a table. Here relay characteristic is given in the form of table. So for a PSM of 10, what is the time taken? 5 seconds. Okay. Now use the time setting multiplier relation. Actual time of operation by time of operation specified by the manufacturer at that PSM. Okay. Now actual time of operation will be how much? 0.3 into 5. How much do you get? 1.5 seconds. So this is how you need to use the PSM and TSM calculations. Okay. So now here we have analyzed how do you adjust different times of operation. How do you adjust the different times of operation? That means how can you get different times for the same current magnitude? How do you adjust the different times of operation? The time of operation mainly depends on two factors. One is the distance that is to be traveled by the relay contact for closing the trip circuit, and the second one is the speed at which relay contact is moving. The speed at which relay contact is moving. Here, you cannot adjust the speed because that speed depends on fault current magnitude. Here, what you can adjust, we can adjust the distance that is to be traveled by the relay contact. If you change the backstop position, the initial rest position changes. So the distance that is to be traveled by the relay contact changes. So here it is in terms of time setting is in terms of time setting multiplier TMS. Actual time of operation by time of operation specified by the manufacturer in seconds at that particular PSM. Okay. So we have solved the problems based on that PSM and TSM. Now, so we have seen the classification of relays based on what? Based on Time of operation we have discussed. Now let us discuss the classification of relays based on application. Okay. Classification classification of relays based on application. Based on application, how can you classify the relays? Let us discuss. Okay. So first one is over current relay. Over current relay. My question is, when this overcurrent relay will be operated? We will see about the construction, all those later. So I am discussing the classification of relays based on application. When the overcurrent relay will be operated? Any idea? Overcurrent relay. The name itself tells what is it is sensing? What the relay is sensing? Current. So whenever the current seen by the relay is more than its set value, the relay is operated. Okay. Overcurrent relay will operate when the current when the current seen by the relay when the current seen by the relay is more than its set value, it will be operated. Okay. It will be operated. Now these overcurrent relays are of two types. One is directional relays and non-directional relays. They are of two types. First one is non-directional relay. And the second one is directional relay. Non-directional relay and directional relay. What is the difference between a non-directional relay and a directional relay? What is the difference between a non-directional relay and a directional relay? Non-directional relay will sense only the magnitude of current. If the relay senses only the magnitude of current, then it is a non-directional relay. It senses only magnitude. It senses only magnitude. But whereas the directional relay senses both magnitude and phase. Here direction is in terms of phase. Here direction is in terms of what, sir? Phase. It senses both. It senses magnitude and phase. It senses both magnitude and phase. So then it is a directional relay. Non-directional relay means it senses only magnitude. Directional relay means it senses both magnitude and phase. So where do you use this overcurrent relay, sir? Overcurrent relays, where do you use? Overcurrent relay will be used in protection of distribution system. It can be used in protection of distribution system. Distribution system protection. Okay, we will discuss about this overcurrent relays later, applications, all those we will discuss. Just I am giving the classification of relays. First one is what? Overcurrent relay. Now next let us go for over voltage relay. Second one is what? Over voltage relay. When the over voltage relay will be operated, what it will sense? The name itself is saying over voltage. When this over voltage relay will be operated, when the voltage seen by the relay is more than its set value. Over voltage relay will be operated when the voltage seen by the relay is more than its set value. It will be operated when the voltage seen by the relay seen by the relay is more than its set value. So whenever the voltage seen by the relay is more than its set value, over voltage relay will be operated. Where it will be used? What is the application of this over voltage relay? What is the application? It can be used in protection of In protection of EHV lines. EHV stands for what? Extra high voltage lines. EHV stands for extra high voltage lines and alternator. Alternator. Alternator is nothing but a synchronous generator. Alternator is nothing but what? Synchronous generator. Okay. This is about over voltage relay. Next up, let us take the next one, that is a distance relay. Okay. Distance relay. Where do you use this distance relay and when it will be operated? Here, the distance protection, it is used in case of transmission lines. Where do you use the distance relay, sir? Distance relays are used in protection of a transmission system. It is used, it is used in protection of transmission system. In protection of transmission system. Transmission system. Okay. In transmission system protection, we'll be using distance relay. When this distance relay will be operated, when the distance relay will be operated, here distance is not physical distance. Here distance is in terms of impedance, reactance and admittance. Here distance is in terms of impedance, reactance and admittance. Suppose if you want to protect this section of line here, if you want to protect this section of line, this section of line is to be protected by a distance relay placed at this location. What it will sense? The set value will be this is the total set distance. This is the Z set value. This is the Z set value. So whenever the short circuit fault takes place, suppose here short circuit fault takes place. This is the fault impedance. So whenever the impedance seen by the relay is less than the set impedance, whenever the impedance observed by the relay is less than the set impedance, the relay will be operated. So when the distance relay will be operated, sir? When the distance relay will be operated? When the distance seen by the relay is less than the set distance. When distance seen by the relay is less than set distance, set distance distance relay will be operated. Distance, it will be operated. Whenever the distance seen by the relay is less than the set distance, it will be operated. Okay, it will be operated. Where to use this distance relays? In protection of transmission system. Okay, just wait, sir. Just wait. Wait for a minute. So where do you use the distance less? In production of transmission system, we will be using the distance less, and it will measure the distance is in terms of impedance, reactance and admittance. We will discuss about this distance less in detail. Okay. So I am giving the classification based on what? Application. This is about distance less. Next, let us discuss about differential relay. Differential relay. When this differential relay will be operated? When this differential relay will be operated, what condition is to be satisfied? Differential relay will be operated when the vector difference between two similar electrical quantities exceeds the set value. Differential relay, it will be operated, when the vector difference, difference between two similar electrical quantities exceeds set value. Differential relay will be operated when, sir? When the vector difference between two similar electrical quantities exceeds the set value. Where to use this differential relay? What is the application of this differential relay? Where to use? It is used, it can be used in protection of protection of alternators, alternator, and bus bar, bus bar, and transformer protection, transformer protection. So differential relay is used in production of what? Alternator, bus bar, and transformer protection. Okay. Now let us discuss reverse power relay. Reverse reverse power relay. Reverse power. Where to use this reverse power relay, and it will be operated when? It will be operated when? Suppose if you consider an alternator. Alternator is delivering power to grid. Alternator is delivering power to grid. So whatever the mechanical input that has been given is converted to electrical power output, and it is being delivered to load. Alternator will deliver both real power as well as reactive power to load. Now, suddenly what happens? If some mechanical input gets failed, if PM gets failed, what happens? The machine will draw real power from grid and it will deliver the reactive power to grid. So here, the real power direction has been changed. The real power direction has been changed. So here, which type of relay we will use to sense this failure of mechanical input or failure of prime mover input? We'll be using reverse power relay. So when the reverse power relay will be operated, it will be operated, it will be operated, it will be operated when the power seen by the relay, when the power seen by the relay, when the power seen by the relay is more than its set value, more than its set value in set direction, in set direction, okay, in set direction. During normal condition, this is the flow of power direction from alternator to grid. But when mechanical input gets failed, the power flow, real power flow direction gets changed. So here we'll be using reverse power relay to sense this failure of prime mover input. Where do you use this? It is used, it can be used, it can be used in protection of alternator, in protection of alternator from loss of mechanical input, mechanical input. Okay, so this is the classification of relays based on what? Application. So we can classify the relays like this based on application. So based on application, how we have classified? First one is overcurrent relay. It can be used in protection of distribution system. It will be operated whenever the current seen by the relay is more than its set value. There are of two types, sir: directional relay and non-directional relay. Directional relay will sense both magnitude and direction. Here direction is in terms of what? Phase. Here direction is in terms of phase. Okay. Non-directional relay will only sense the magnitude. Okay. Where to use directional and where to use non-directional, that is important. We will discuss in applications. Okay. Next, over voltage relay. Over voltage relay will be operated when voltage seen by the relay is more than its set value. Where do you use this over voltage relay? In protection of extra high voltage lines and alternator protection. Alternator protection. Distance relays. Where do you use distance relay? Distance relay is used in protection of water transmission system. And just introducing here, we'll discuss about all these relays in detail. Okay. Distance. Here, distance is not the physical distance. It is in terms of what? Here, distance is in terms of impedance, reactance, and admittance. Impedance, reactance, and admittance. So when the distance relay will be operated, when the distance seen by the relay is less than the set distance, it will be operated. Next one is differential relay. Differential relay, it will be operated when the vector difference between two similar electrical quantities. When the vector difference between two similar electrical quantities exceeds the set value, differential relay will be operated. So where do you use this? It can be used in protection of what? Alternator, bus bar, and transformer. Okay, differential relay. Next one is reverse power relay. Reverse power relay. When it will be operated? Whenever the power seen by the relay is more than its set value in set direction. So where do you use this reverse power relay? It is used in protection of what? Alternator from loss of mechanical input or prime mover input. When mechanical input or prime mover input gets failed, it draws the real power from the grid. So to sense this, we'll be using which relay, sir? Reverse power relay. So this is the classification of relays based on what? application. Okay. Next, let us classify the relays based on construction. Classification, classification of relays based on construction. Based on construction, how can you classify the relays? Let us discuss. Okay. First one is electromagnetic attraction type relays. Electromagnetic attraction type relays. Attraction type. So in this electromagnetic attraction type relays, operating force is developed. I think in the last class I said relay contact will experience two forces. One is operating force and the other one is what? Restraining force. In case of electromagnetic attraction type relays, operating force is developed by which principle? Electromagnetic attraction principle. Electromagnetic attraction principle. Here we have different types. One is attracted armature type, relay. This attracted armature type relay, balanced beam type relay, solenoid type relay, and moving iron type relay, iron type relay, moving iron type. All these relays will operate based on which principle? Electromagnetic attraction type principle. So all this comes under that class. So generally objective type question may be asked like this. These relays can sense AC quantities or DC quantities or both. These relays can sense AC quantities or DC quantities or both. These electromagnetic attraction type relays can sense both AC quantities and DC quantities. These relays can sense what? Both AC and DC quantities. DC quantities. Okay. Electromagnetic attraction type relays can sense both AC quantities as well as DC quantities. This was IES question asked. Engineering services. Question was asked in objective type. Electromagnetic attraction type relays can sense AC quantities or DC quantities or both. They can sense what? Both AC quantities as well as DC quantities. Okay. Now let us go for the next one. Second one is electromagnetic induction type relays. Electromagnetic induction type relays. Induction type relays. Electromagnetic induction type relays. So in this electromagnetic induction type relays, operating force is developed by what? Electromagnetic induction principle. Operating force is developed by electromagnetic induction principle. Here there are of three types. Electromagnetic induction type relays are of three types. One is shaded pole type relay, shaded pole type relay. Second one is watt hour type relay, Based on this electromagnetic induction type principle, there are three types. Third one is induction cup type relay. Now there was one was IES bit, IES objective type question. Engineering services objective type question asked this electromagnetic induction type relays can sense AC quantities or DC quantities or both. AC quantities or DC quantities or both. This induction principle is only for what? AC quantities. Induction principle is only for AC quantities, not for DC. So electromagnetic induction type relays. These it can be used or electromagnetic induction type relays can be used for sensing AC quantities only. They can sense what? AC quantities only. They cannot sense DC quantities. Okay. They cannot sense DC quantities. DC quantities. They cannot sense DC quantities. They can be used for sensing only AC quantities. They can be used for sensing only AC quantities. Okay. Now next go for third one, that is electrothermal relays. Electrothermal relays. Electrothermal relays. In this electrothermal relays, we'll be using what? Temperature sensing devices. In this electrothermal relays, what will use? We'll be using temperature sensing devices. Temperature sensing devices are used. Are used. Temperature sensing devices are used. What are the temperature sensing devices? Example what? Example is thermocouple. Thermocouple. Thermocouple is used, and bimetallic strip. Bimetallic strip. Thermocouple or bimetallic strip can be used in case of this electrothermal relay. Temperature sensing devices are used. Okay. Fourth one is electrostatic type relay. Electrostatic type relay. In this electrostatic type relays, there will not be any moving parts. Here we will be using semiconducting devices. We'll be using semiconducting devices such as operational amplifiers and comparators will be used in case of electrostatic type relays. Okay, and next one is physico relays. Okay, physico relays. That means these relays will sense the change in physical conditions. Some relays operate based on sensing the change in pressure of gas. Can anyone say example of a relay which senses the change in pressure of gas? I think you have studied about transformer. In transformer, there will be a relay which is known as Buckel's relay. Buckel's relay, which will sense the change in pressure of gas. Okay, because some relays operate based on sensing change in pressure of gas. Change in pressure of gas. They are known as physical relays. Example is what? Buckel's relay. Example is what? Buckel's relay. Buckel's relay used in transformer protection. We'll study about this Buckel's relay in detail. Okay. We'll study how the Buckel's relay will operate. We'll study later. Okay. Buckel's relay is used in transformer protection. In transformer protection. Okay. These are known as physical relays. So this is about the classification of relays based on what? Construction. Based on construction, how many different types? Here, electromagnetic attraction type relays. Okay, this relays operating force is developed by what? Attraction principle. In this relays, operating force is developed by attraction principle. They can sense both, sir, AC quantities as well as DC quantities. They can sense both AC quantities and DC quantities. Coming to the electromagnetic induction type relays, operating force is developed by induction principle, but they can sense only AC, quantities only. They cannot sense DC quantities. Okay, and electrothermal relays, electrostatic type relays, and physico relays. Okay, this is about the classification of relays based on what? Construction. This is the classification of relays based on construction. Now let us go for the relays construction in detail. How the relays are constructed in detail. Okay. So first one. Now let us learn about electromagnetic attraction type relays. Let us learn about electromagnetic attraction type relays. Attraction type relays. Let us learn about electromagnetic attraction type relays in detail. So, in this electromagnetic attraction type relays, operating force is developed by what? Electromagnetic attraction principle. In this relays, operating force is developed by attraction principle. Electromagnetic attraction principle. That's why they are known as what? Electromagnetic attraction type. There are different types I have given. First, let us discuss about attracted armature type relay. Attracted armature type type relay. Let us discuss about this attracted armature type relay. So, if you observe the construction of this attracted armature type relay, it consists of a fixed electromagnetic core. Here, if you observe, I will go in the next page. So, there will be a fixed electromagnetic core like this, same as your transformer core. There will be a fixed electromagnetic core. This is fixed electromagnetic core. It is a fixed electromagnetic core. Over this fixed electromagnetic core, a relay coil will be placed. Here, what will place a relay coil? This is the relay coil that has been placed on this fixed core. Okay. Apart from this fixed core, there will be CT. Apart from this fixed core, there will be a mobile armature. Here you have what? Mobile armature, which is allowed to. This mobile armature can be rotated. Movable armature. Okay. So this movable armature, at the end, relay contact will be attached. Here, what will be attached? At the end of this movable armature, there will be a relay contact. Relay contact attached at the end. Relay should operate during normal condition or abnormal condition. During normal condition only, the relay should operate. To restrict the operation of the relay during normal condition, here the restraining force is developed by what? Spring. Here we'll use spring to develop the restraining force. FR. Spring is used to develop the restraining force. Here you have two trip contacts. These contacts will be connected to what? Yes, sir. These contacts will be connected to what? Trip circuit. Okay, trip circuit. Now let us observe how this attracted type armature type relay will be operated. Okay. Here in the yesterday's class, I have given relay and circuit breaker configuration. Relay and circuit breaker configuration that I have given in the yesterday's class. Now observe here the relay coil that I have connected to the CT secondary side. This is the coil. This is the coil which is connected to CT secondary side. If you want to sense current, you can excite with CT. If you want to sense voltage, you can excite with CT. Okay. If you want to sense current, connect to a CT. If you want to sense voltage, you can connect with a PT. Okay. Whenever you are connecting this coil to the CT or PT, what happens, sir? Whenever you are connecting the coil to the CT or PT, what happens? It draws the current. It draws the current and it establishes the flux. It is electromagnetic core, no? It establishes the flux. And this flux will complete its path like this. This flux will be completing its path like this. Okay? This is the flux completion path. Okay. So here flux is emerging out. It behaves as north pole. It behaves as what? South pole. Flux is emerging out. It behaves as north pole. It behaves as south pole. Opposite poles will attract. Opposite poles will attract. So this will develop the operating force like this. Operating force. Okay. Now observe here. When short circuit fault takes place, what happens? Current magnitude increases. When short circuit fault takes place, current magnitude increases. When current magnitude increases, flux developed also increases. Flux will also increase. The force experienced by the movable armature will be increased. The operating force increases. If not increases, then the movable armature will be attracted downward and this relay contact will slowly move and it will close the trip circuit like this. And the relay contact will slowly move and it will close the trip circuit. This is how an attracted armature type relay will operate. Now let us discuss about, I'll give the points what this relay will have. This attracted armature type relay will have what? It consists of fixed electromagnetic core. Electromagnetic core over which relay coil is placed. Relay coil is placed. So over this fixed electromagnetic core, this is a fixed electromagnetic core over which relay coil is placed. and this relay coil can be excited with CT or PT. Okay, it can be excited with, it can be excited, it can be excited with CT or PT. If you want to sense current, connect with CT. If you want to sense voltage, you can excite with the PT. Okay. It also consists of this mobile armature also. This electron attracted armature type relay. Here it is also consisting of what, mobile armature. It also consists of mobile armature. Mobile armature to which a relay contact is attached at the end. Attached at end. At the end of the relay contact, at the end of this mobile armature, relay contact is attached. So here, the restraining force. How we are developing the restraining force or opposing force? Relay should operate only during abnormal conditions. For that, the restraining force is developed by what? Spring. The restraining force is developed by spring. Okay. In order to restrict, in order to restrict the operation of the relay, during normal condition, during normal condition, the restraining force is developed. The restraining force is developed by using spring. Here, what is the purpose of the spring that you have connected? To develop the restraining force. Okay. Now, what happens when short circuit fault takes place? When short circuit fault takes place, current magnitude increases, flux increases, operating force increases. The mobile armature is attracted downward, and it will close the trip circuit, and it will close the trip contacts. Now observe here. Whenever the short circuit fault takes place, what happens? Current magnitude increases. So the flux increases. So this mobile armature will experience more force, so that this will be attracted downward. Then this relay contact will close the trip circuit and the relay will operate. So this is how an attracted armature type relay will be operated. Okay. Now let us see how the mathematical analysis of this attracted armature type relay. Let us observe. Okay. So mathematical, how can you analyze? How can we observe? Okay. Operating force expression, how do you derive? What is the energy stored in that electromagnetic field? So if you observe this diagram, let the distance from this mobile member to the fixed member be some x. So in this electromagnetic field, what is the energy stored? Energy stored in electromagnetic field. Energy stored in electromagnetic field. How do you calculate WFLD equal to what? Half Lx I square. Is the energy stored in electromagnetic field. So what is the operating force? Once you know the energy stored, what is the operating force developed? F naught. Operating force expression is what? F naught. How do you calculate? dWFLD by dx. If it is moving at a segment of dx, so the force developed is F naught is equal to dWFLD by dx. So how do you calculate? F naught is equal to d by dx of half Lx I square. Here inductance is the function of the displacement. So now the operating force expression F naught is equal to half I square into dlx by dx, half I square into dlx by dx. So if you observe this, operating force is directly proportional to what? I square. Operating force is directly proportional to I square. So F naught is directly proportional to operating quantity square. Operating quantity square. So in case of this attracted armature type relays, the operating force is directly proportional to what? Square of the operating quantity. So operating force. This is very important, sir. Objective type question asked in Transco. Operating force is directly proportional to proportional to what? Square of operating quantity. Operating quantity. The question was given like this. Operating force directly proportional to operating quantity, square of the operating quantity, cube of the operating quantity power 1 by 2. So it is directly proportional to what? Square of the operating quantity. It is directly proportional to square of the operating quantity. Okay. So that is important. So once we got this, operating force is directly proportional to operating quantity square. Operating quantity. So we can rewrite this as some constant K1 into operating quantity square. Some constant K1 into operating quantity square. Here restraining force, how we are developing, sir? Restraining force, how we are developing? By using what? Spring. Restraining force. Restraining force. That is nothing but opposing force. Is developed by what? Is developed by spring. Spring you are using to develop the restraining force. So the force developed by the spring, Fr is some constant K2. Fr is some constant K2. Okay. For relay operation, what condition must be satisfied? When the relay will be operated, what condition must be satisfied for relay operation? When operating force is greater than the restraining force. When operating force is greater than the restraining force, the relay will operate. When F naught is greater than Fr, relay operates. Relay operates. Okay. I have said this, electromagnetic attraction type relays can be used for sensing both AC quantities as well as DC quantities. This attracted armature type relay can be used for sensing both AC quantities as well as DC quantities. Now let us verify whether it is sensing both AC quantities and DC quantities or not. So for sensing is for DC quantities, for sensing, first let us take IDC, DC current. Now operating force is equal to some constant K1 into what? Operating quantity square. Operating quantity square. Here what is the operating quantity? DC current. F naught is equal to K1 into IDC square. K1 into IDC square. Restraining force is what? Constant K2. Restraining force is constant K2. For relay operation, what condition must be satisfied? For relay operation, what condition must be satisfied, sir? Here operating force should be greater than the restraining force. Operating force is what? K1 IDC square. K1 IDC square greater than what? K1 IDC square greater than K2. So here when IDC is greater than under root of K2 by K1, IDC is greater than under root of K2 by K1, the relay operates. That means here under root of K2 by K1 is nothing but the set value of the relay. Set value of the relay. So whenever the current seen by the relay is more than its set value, the relay is operating or not? The relay will operate. Here whenever the current seen by the relay is more than its set value, the relay is operating. Understood my point? Whenever the current seen by the relay is more than its set value, here the relay is operating for DC currents. Now let us check for AC currents. For AC currents, for sensing IAC, AC currents. Okay, AC current means time varying current. Okay, time varying quantity. Let this IAC, AC quantity be IM sin omega t. IM sin omega t. It is a time varying quantity. IAC is equal to IM sin omega t. Now operating force is equal to what? K1 into operating quantity square. Operating quantity square. So operating force is equal to K1 into here operating quantity is what? IM sin omega t square. So you can rewrite this equation as what? You can rewrite this equation as K1 into Im square into sine square omega t. Sine square omega t. So operating force F naught is equal to K1 into Im square into How do you write sine square omega t? How do you write sine square omega t? How do you write sine square omega t? Any idea? Trigonometrically, how can you express 1 minus cos 2 omega t by 1 minus cos 2 omega t by sine square omega t can be written as what? 1 minus cos 2 omega t by 2. So operating force F naught is equal to K1 into Im square by 2 minus K1 into Im square by 2 into cos 2 omega t. Okay. Now, if you observe this operating force expression, it is consisting of two terms. This first one is fixed. Operating force consisting of two terms. First one is fixed. This is second one, whatever the term that you are having, which is a time varying quantity or not. It is a time varying quantity. Second one is time varying quantity. So, it is consisting of double frequency component 2 omega t. So what is the effect of this term on the operation of the relay? Okay. What is the effect of this term on the operation of the relay? What happens? Observe here. So due to that time varying term in the operating force, what happens? This movable armature, whatever the movable armature here it is shown, it is continuously experiencing pulsating oscillations. It will experience what? Pulsating oscillations. So whenever it is experiencing pulsating oscillations, this relay contact may strike the trip contacts, and there may be spark formation that may result in formation of sparks at the relay contact, and the relay contact may get damaged. Listen here carefully. Due to the time varying term, the movable armature may experience continuous oscillations. Due to the continuous oscillations, that relay contact may frequently strike the trip contacts, and spark formation may take place, and the relay contacts may get damaged. So this is the limitation here. This is the limitation. Okay. Right. Here, the operating force. The operating force consists of two terms. One is fixed, and the other is variable, due to the variable term variable term, the movable armature experiences continuous oscillations, which may result in formation of spark at relay contacts, and relay contacts may get damaged, and relay contacts may get damaged. Okay. So frequent replacement is required. So frequent replacement is required. So frequently we need to replace the contact. So that is the limitation. It is sensing both, no doubt. Here it is sensing this relay is sensing both the AC quantity and DC quantity. But there is a limitation. In sensing what AC quantities. There is a limitation in sensing AC quantities. Due to that variable force, what is happening? The mobile armature is experiencing continuous oscillations, and it is damaging the relay contact. So to avoid that, for sensing AC quantities, we'll be using electromagnetic induction type relays. For sensing AC quantities, what will be using? Electromagnetic induction type relays will be using. Okay. So up to now we have discussed about this electromagnetic attraction type relays. I will just revise this. This electromagnetic attraction type relays, operating force is developed by what? Attraction principle they can sense what? They can sense both. Sense both AC and DC. AC as well as DC. They will sense both, sir. AC and DC. Okay, attracted armature type relay. So if you observe this attracted armature type relay, it consists of fixed core and mobile armature. Over this fixed core, you have a relay coil. This can be excited with CT or PT. If you want to sense current, excite with CT. If you want to sense voltage, excite with PT. So whenever you are connecting the CT or PT, it will draw the current and it will establish the flux. So here flux is emerging out, it behaves as north pole. Flux is coming in, it behaves as south pole. So unlike poles, attract. So this is the operating force developed. If there is only operating force, relay will operate during what? Normal condition also. To restrict the operation of the relay during normal condition, the restraining force is developed. The restraining force is developed by what? Spring. Spring is used for developing the restraining force. What happens when short circuit fault takes place? When short circuit fault takes place, current increases, flux increases, force developed increases, and the relay contact will close the trip circuit. Okay, that is the operation of the relay. Okay, so operating force is directly proportional to what? Square of the operating quantity. Restraining force is developed by the spring. Fr is equal to K2. For relay operation, F naught should be greater than Fr. So we have checked for DC quantities. So whenever the current seen by the relay is more than its set value, the relay is operating. Here also for AC quantities, the operating force is developed. It is consisting of two quantities. One is fixed and the other one is time varying. If this double frequency component, the mobile armature will experience continuous oscillations and it may damage the relay contact due to formation of sparks. Okay. To avoid this, for sensing AC quantities, we'll be using what? Electromagnetic induction type relays. We'll be using which type of relays? Electromagnetic induction type of relays. Okay. So now what I will do is I will lower all your hands. If you have any doubts, you can ask, sir. You can raise your hand. I will allow you to talk. If you have any doubt, you can ask. By raising your hand, you can ask. If you have doubt, you can ask. Shivanand,
Hello, sir.
ask your doubt.
Sir, please give us some time to note down, sir. We are
Okay.
at season and
Uh,
we're
okay.
at the same.
Okay. Right.
Thank you, sir.
Actually, we are sharing the notes, no? That's why.
Okay, sir.
Okay. Naga Teja.
Good evening, sir.
Naga Teja. Ask your doubts.
Sir, what is the significance of flux setting multiplier, sir?
That is PSM.
Yes, sir. PSM.
See here. Now, if you observe this problem, here it has shown the characteristic. Characteristic of the relay is in terms of PSM, flux setting multiplier, and time of operation. So, if you change the distance that is to be traveled by the relay contact, time of operation changes. But here, this time of operation that is specified is for what? The total rotation, that is 100% rotation. Okay, 100% distance that is to be traveled. Here, the time of operation depends on two factors. One is distance that is to be traveled and the fault current magnitude, as well as relay setting also. If you observe the PSM relation, it includes the fault current as well as relay setting. So for identifying the characteristic, we require that PSM and PSM calculations.
Okay, sir.
It depends on both, no? Here fault current as well as relay setting.
Okay. Thank you, sir.
Okay. Jitendra,
Hello.
ask your doubt.
Sir, I wanted to know whether what you have been teaching is just the part of EAC syllabus or is it for GATE also?
It is for both ESC, GATE, and PSC.
Okay, sir. So everything like this theory and everything for GATE also, sir?
Uh, Mostly, nearly only 5 to 10% variation will be there, but this will be useful for both.
Okay, sir. Thank
Only
you.
5 to 10% variation will be there.
Okay, that's what I wanted to know. Thank you.
Okay. B. Sai Charan Reddy.
Sir, what is the difference between differential relay and reverse power relay, sir?
So differential relay we will study in detail later, uh, because here I have given only the classification of relays. No? We have discussed only the classification of relays. The differential relay is one chapter that we will discuss later. It will, suppose if you want to protect this electrical equipment, whatever it may be, the transformer or busbar or alternator. In differential relay, what you will do? We will connect the CDs on both sides, and we will compare the currents here by connecting the CDs. Okay. So this is the differential. Here it will operate whenever the vector difference between two similar electrical quantities exceeds the set value. Okay. So differential relay is a separate chapter, sir, that we will discuss later. Okay. Okay. Only the classification I have given. I have not given the total analysis of the differential relay. We will discuss about the differential relay in detail. Okay. Nanda Kumar.
Hello, sir.
Ask your turn.
Sir, how it is DC current greater than K2 by K1? It is set value, sir.
Here you got no K1 IDC square greater than K2. IDC take this K1 on the other side, under root of K2 by K1. This is nothing but the set value of the relay. So whenever the current seen by this is the current observed by the relay is greater than the set value, the relay will operate.
K is constant, no, sir.
These two are constant.
Oh, okay, sir. Next, this electromagnetic relay is used only for short circuit faults, sir.
No. Here I have shown the diagram. No, if you want to sense the voltages, also you can use this. But here you should excite with what PT. Here I have shown. If you want to sense current, you can excite with CT. If you want to sense voltage, you can excite with PT.
Okay, sir. Thank you, sir.
Srinaya V.
Sir, good evening, sir. My doubt is that there is any difference between pickup value and set value, sir?
Set value and pickup value both are same.
Okay, sir. Thank you, sir.
Nayan.
Hello, sir.
Ask your doubt.
Sir, please, sir, can you share the notes after immediately class, sir?
Actually, I have forwarded this file to the admin department. They have to upload. I have already informed them to upload. I will again inform them to upload.
Okay, sir.
Salman Raj. Salman Raj. Vaishnavi.
Sir, in 8F, sir.
8F. Ask your doubt.
Sir, you said here second formula, no, sir. Fault current on secondary side by relay pickup value. Can you explain this again, sir?
Here, suppose if primary side current is 200 amperes, CT ratio is 400 by 5. Secondary side current will be how much? 2.5. Okay.
Secondary side will be same as CT rated current only, no, sir?
No. Here, CT ratio 400 by 5. Primary side 400 means secondary side will be also half. How much? 2.5.
Oh, okay, sir. 2.5.
So
Okay,
primary fault current on primary side is 200 by CT ratio. CT ratio is 400 by 5. This will be how much? 2.5.
Okay. Okay.
So that is nothing but fault current on CT.
Okay, sir. What is the weightage for this subject, sir, in GATE?
In GATE, for this total, you may get around 5 marks. Okay.
Okay, sir.
This protection, load frequency control, and economic load dispatch.
Okay, sir. Okay, sir.
Shivaji.
Hello, sir. Good evening, sir.
Uh,
Sir, can you explain me what you mean by relay setting, sir?
Relay setting. That is the current setting. That is the current setting. Suppose if your set value, if the rated current of the relay is 10 amperes, okay?
Okay, sir.
10 amperes. But if you want to set, that is nothing but 10 amperes is 100%. 10 amperes is 100%. But if you want to set to 120%, plug setting at 120%. then that means it will operate beyond that 12 amperes of current.
Yes, sir. And sir, plug setting multiplier, is it a ratio or there is some theory?
It is a
behind it, sir?
ratio only, here the fault current on relay side by relay pickup value. Ratio, current to current ratio.
Okay, sir. Sir, and then 29F, sir.
Huh?
29F.
29F. Ask her.
Sir, how here FR will become a constant, sir?
The force developed by the spring at that particular instant will be constant. Suppose if you apply the force on the spring and the force applied by you is constant, that means same, that is not variable. The force developed by opposition force developed by the spring will be also same.
Okay, sir. So we are considering it at for that instrument.
Yeah,
okay, sir. Okay, sir. Thank you, sir.
Shelluri Sharath.
Sir,
Ask your doubt.
actually, I have a doubt on problems setting multiplier.
Okay, what is your doubt?
Sir, in that the relay setting is given 120% of load current.
Okay.
But here you have taken the relay setting as only 120%, so 120 by 100.
I'll
120 by 100 into full load current.
Here 120 by
100
relay setting, how much given? Relay setting in this problem, suppose. Relay given as 120% of full load current. No?
Yes, sir.
Then relay pickup value that I have calculated. No, relay setting. Relay setting is 120% of rated current of the relay. Full load current means rated current of the relay.
But actually here in question, relay setting is given 120% of full load current. No, sir.
That is a full load means here rated current.
Okay, sir. Yeah, sir. Actually, I have one suggestion, sir.
Okay.
Actually, you are going too fast, sir. You can slow a little bit, sir.
Okay.
Yes, sir. Yes, sir. Thank you, sir.
Hello.
Ask your doubt.
How open circuit fault is cleared, sir?
How?
Open circuit fault. Because when circuit breaker is opened, it is open circuit fault, right?
No, not like that. Here, unwanted. Mute from your side, sir. Mute from your side. Here, open circuit fault is not due to the opening of circuit breaker. Unwanted opening of circuit breaker contact. Suppose if you take the three phases, suppose if the this circuit breaker contact of A phase got open, but the two phase is kept in a closed position. So this will create an open circuit fault. Unwanted opening of circuit breaker contact will create an open circuit fault.
Okay. When there is a line ground fault, LG fault.
Okay.
Only one phase circuit breaker will open.
No. We are operating the system under balanced mode. All the three phases should be disconnected.
Okay. Yeah. That was my doubt. Thank you, sir.
Okay, mute from Ajay Devadas.
Hello, sir. Good evening, sir.
Good.
Sir, I have a problem related to recorded videos and slides, sir. I just wanted to say that if you could tell them to upload the videos on the next day morning or at least 4 or 5 hours before the next lecture, so that I could revise lecture.
Okay, I will inform them.
No, sir. At least 5-6 hours before lecture.
Okay, I will inform them, sir.
Thank you, sir.
Okay, let us take a break. for 15 minutes. Come back at Welcome back. So welcome back. I request the students to just check my voice. If audio and video is clear, just raise the hand. If audio and video is clear, just raise the hand, sir. If audio and video is clear, just raise the hand. Okay, sir, you are asking to go slow. I am repeating 3 times. Okay, I'll decrease my speed. Okay, no, no problem. We will go slow, sir. If audio and video is clear, is audio and video clear? Okay, right. Okay, sir, we'll go slow. No issue regarding that. Okay, right. So we have discussed about this electromagnetic attraction type relays. Okay, in this relays, operating force is developed by what? Electromagnetic attraction principle. It consists of what? Fixed electromagnetic core over which relay coil is placed. I have given the diagram of this. This is the fixed electromagnetic core over which relay coil is placed. This relay coil is connected to CT secondary side or PT secondary side. If you want to sense current, connect with CT, or if you want to sense voltage, you can connect with PT. Okay. If you want to sense current, you can connect with the CT, or if you want to sense voltage, you can connect with PT. Just a minute, sir. Now, whenever this relay coil is excited with a CT or PT, what happens? It draws the current. It draws the current and establishes the flux like this. Okay. So this flux is emerging out here. It behaves as north pole. It behaves as south pole. Okay. Now, whenever the short circuit fault takes place, current magnitude increases. Flux is nothing but MMF by reluctance, magnetomotive force. MMF means what? Magnetomotive force. When current increases, flux increases. So the operating force developed increases. So this mobile armature, which is allowed to move, is attracted downward. Then this relay contact will come and close the trip circuit. This relay contact will come and close the trip circuit, and the relay will operate. Okay. So this is how the relay operation will be done, and we have gone through the mathematical analysis of this. Energy stored in electromagnetic field, half Lx I square. So operating force that we have derived is directly proportional towards square of the operating quantity. Very important point, sir. Operating force is directly proportional to square of the operating quantity. Okay. Here restraining force is developed by what? A spring. So that is constant. So I have said these relays can be used for sensing both AC quantities as well as DC quantities. Here I have shown for DC quantities, IDC. Okay. So for DC currents, it is sensing, no issue with the DC currents. But coming to the AC currents, that is time varying current. Here the operating force developed has two quantities. One is fixed, this one is fixed, and this is variable. And this variable term consisting of double frequency component. Due to this double frequency component, what happens? The movable armature will experience continuous oscillations. Continuous oscillations. Due to the continuous oscillations, what happens, sir? The relay contact may strike the trip contacts, and sparks may be formed. It may result in what? A spark formation. Relay contacts result in sparks at the relay contact, and the relay contact may get damaged. So frequent replacement is to be done. To avoid that, for sensing AC quantities, we prefer what? For sensing AC quantities, we prefer what? Electromagnetic induction type relays. We prefer which type of relays, sir? Electromagnetic induction type relays. Okay. Now let us discuss about this electromagnetic induction type relays. Okay. Just a minute. Electromagnetic induction type relays. Induction type relays. Now let us see how these electromagnetic induction type relays are constructed and what are the requirements of electromagnetic induction type relays. So in these relays can be used for sensing AC quantities only. They cannot sense DC quantities. Okay, they can be used. They can be used for sensing AC quantities only. They can be used for sensing AC quantities only. They cannot sense DC quantities. They cannot sense DC quantities. They cannot sense DC quantities. They can be used for sensing only AC quantities. They cannot be used for sensing DC quantities. Okay. Now, what are the basic requirements for using this electromagnetic induction type relays? For developing this electromagnetic induction type relays, what are the basic requirements? Now let us see. Okay, so the basic requirements are first one is the basic requirements are two working fluxes are required. Two working fluxes are to be developed. So how do you develop two working fluxes? So there are two techniques. One is split phase technique. And the second one is quadrature winding mechanism. Quadrature winding mechanism. So you can use either split phase technique or quadrature winding mechanism for developing these two working fluxes. Okay. Now, once you develop these two fluxes, they must be with certain phase displacement. Two working fluxes. Second one is two fluxes with certain phase displacement. So two fluxes must be with certain phase displacement. Okay. So basic requirements are what? Two working fluxes are required and with certain phase displacement in case of electromagnetic induction type relays. Now let us see what happens. And these two fluxes are to be linked with aluminum cup or aluminum disc. Okay. The phi 1 comma phi 2 are to be linked with what? Are to be linked with aluminum cup or aluminum disc. They are to be linked with aluminum cup or aluminum disc. Okay. Now what happens? Observe here. There are two fluxes phi 1 and phi 2 which are being developed either by split phase technique or quadrature winding mechanism. Split phase technique or quadrature winding mechanism. Now these two fluxes are being linked with an aluminum cup or aluminum disc. Are to be linked with aluminum cup or aluminum disc. When these two fluxes are linking with aluminum cup or aluminum disc, what happens? There will be two induced EMFs, E1 and E2. According to which law? Faraday's law. According to which law, sir? Faraday's law. When time varying flux links with aluminum cup or aluminum disc, there will be an induced EMF. EMF. So there will be induced EMF E1 and E2. As aluminum disc is a closed circuit or open circuit, sir? Aluminum disc is a closed circuit or open circuit? Aluminum disc is a closed circuit. So due to this EMF, there will be current circulated in the disc I1 and I2. There will be two currents circulated in the disc I1 and I2. Now interaction of flux with current will develop the force. Interaction of flux phi1 with current I2 will develop one force, and interaction of flux phi2 with current I1 will develop one more force. So here two forces are developed, operating forces, F0 and F0 dash and F0 double dash. So what is F0 dash? Interaction of flux phi1 with current I2. F0 double dash is interaction of flux phi2 with current I1. So resulting operating force is the difference of these two forces. Resulting operating force is the difference of these two forces. Now let us, how do you write this? Phi2 I1 difference of phi1 I2. Okay. So this is the expression for resulting operating force developed in case of what? Electromagnetic induction type relays. Okay. So I have started this electromagnetic induction type relays. They can be used for sensing what? Only AC quantities. They can be used for sensing only AC quantities. They cannot sense DC quantities. Okay. They cannot sense DC quantities. Here, what are the basic requirements? What are the basic requirements? Here the basic requirements are two working fluxes are to be developed. How do you develop two working fluxes? Either by split phase technique or quadrature winding mechanism. Either by split phase technique or quadrature winding mechanism, we can get two fluxes. Okay. These two fluxes must be with certain phase displacement. These two fluxes must be with certain phase displacement. So phi1 and phi2 are to be linked with aluminum cup or aluminum disc. So when these fluxes are linked with aluminum cup or aluminum disc, there will be an induced EMF according to which law? Faraday's law. So aluminum disc is a closed circuit or open circuit? Closed circuit. So whenever there is an EMF and a closed circuit, it will drive the current or not? So there will be two currents in the disc, I1 and I2. Interaction of flux with current will develop the force. Okay, this is the operating force developed. I have said that electromagnetic induction type relays, in case of electromagnetic induction type relays, there are three configurations. What are those? One is shaded pole type relay. Second one is watt-hour type relay. Third one is induction cup type relay. Okay. So we need to analyze these three relays: shaded pole type relay, watt-hour type relay, and induction cup type relay. So we have three different configurations: shaded pole type relay, watt-hour type relay, and induction cup type relay. Now let us take the first one, that is shaded pole type relay. Let us discuss the first one, that is just wait. Shaded pole type relay. Let us analyze. In the shaded pole type relay, how the two fluxes are developed. So the two fluxes will be developed by split phase technique. In case of shaded pole type relay, two working fluxes. How you are getting? By split phase technique. I will explain that in detail. Just listen. Okay. Two fluxes are developed by split phase technique. Okay. So how we are developing the two fluxes? By split phase technique. Okay. Now how the shaded pole type relay is constructed? Now let us see. Okay. So here, in case of shaded pole type relay, listen this carefully. Here you have electromagnetic core similar to that of your transformer core. There will be an electromagnetic core similar to that of your transformer core. So on this electromagnetic core, a relay coil is placed. Here what is placed, sir? A relay coil. On this electromagnetic core, what is placed, sir? A relay coil is connected on this electromagnetic core, and this relay coil can be excited with CT or PT. It can be connected with CT for sensing the current or PT for sensing the voltage. If you want to sense current, you excite with CT. If you want to sense voltage, you excite with PT. So what happens whenever it is excited with CT or PT, it draws the current and it establishes the flux in the core. It will establish the flux in the core like this. So it will establish the flux in the core like this. Okay. Now, here what is the basic requirement? Basic requirement is two fluxes. Basic requirement is two working fluxes. But here we have only one flux which is obtained due to relay coil excitation. Okay. Now, here we will split the core. This core has been splitted into two parts. Now, let's observe here. This core will be splitted like this. This core has been splitted into two parts. So what approach we are using? Split phase. So here the flux which is obtained due to relay coil excitation is being splitted into two parts. By what? Dividing the core. By dividing the core. Okay. So in case of shaded pole type relay, what you can write? In case of shaded pole type relay, two fluxes are obtained by splitting the core. Okay, here two fluxes how you are obtained? By splitting the core and dividing the flux and dividing the flux which is obtained due to relay coil excitation. Relay coil excitation. Okay. So here the two fluxes phi 1, one flux is phi 1 and the other flux is phi 2. Here we are getting two fluxes. By splitting the core, by dividing the core, we have split the flux into two parts. Okay, that is nothing but split phase technique. And one requirement is satisfied. The second requirement is these two fluxes must be with certain phase displacement. How do you get the phase displacement between the fluxes? Here we will be using a shading band. Here what you use? Here a shading band will be used to obtain the phase displacement between the two fluxes. Okay, this is the shading band. What is the purpose of the shading band? Shading band is nothing but a copper coil. Shading band is what, sir? It is a copper coil placed on the segment. So this copper coil will induce what phase? Coil is nothing but inductive in nature. It will induce lag phase. Lag phase. So phi 1 will be lagging phi 2. So the two fluxes will be out of phase. The phase displacement between the two fluxes is obtained by what? Shading band. Okay. The phase displacement between two fluxes. Is obtained by using shading band. What is the purpose of the shading band, sir? Here to obtain the phase displacement between two fluxes. Now these two fluxes are to be linked with an aluminum disc. Here in between the part which the core has been divided, we will place what? Aluminum disc. This is aluminum disc. Now these two fluxes are linking with this aluminum disc. To this aluminum disc, a relay contact will be attached. Here, this is the relay contact. This relay contact will be rotated. This disc will be rotated whenever the disc experiences the force, and it will close the trip contacts, and it will close what? Trip contacts. Okay, this is how a shaded pole type relay consists of. So it consists of fixed core, and over this fixed core relay coil is placed. Whenever you excite with CT, it will sense current. If you want to excite with PT, it will be sensing the voltage. So when you are connecting CT or PT, it will draw the current. It will draw the current and it will establish the flux. The flux which is obtained due to this relay coil excitation is being splitted into two parts. Is being splitted into two parts by dividing the core. Here you have divided the core. That is important. And the phase displacement between two fluxes is obtained by what? Shading band. What is the purpose of shading band here? To obtain a phase displacement between the two fluxes. What is this shading band? It is a copper coil. It is a copper coil. Okay. Understood my point? Now let us mathematically analyze. This shaded pole type relay. Now let us mathematically analyze this shaded pole type relay. So mathematical analysis, how can you do? Here you have two fluxes. One is flux in the shaded portion and the other one is flux in the unshaded portion. Shaded portion is flux is what? Phi1. Unshaded portion flux is Phi2. Okay. So flux in the shaded portion, flux in the shaded portion is that shaded band region flux. Let it be phi1 is equal to phi m1 sine omega t. Okay, phi1 is equal to phi m1 sine omega t. This is the flux in the shaded portion. Unshaded flux in the unshaded portion, let it be phi2, let it be equal to phi2, that is phi m2 sine of omega t plus phi m2 sine of omega t plus phi. So if you observe here, phasor diagram if you plot, phi1 and this is phi2. Phi1 lags phi2 by phase of phi. Here phi is what? A phase displacement between the two fluxes. Phi is what? Here phase displacement between two fluxes, phi1 comma phi2, understood? Now, so whenever a time varying flux links with the aluminum disc, what happens? There will be induced EMF or not? Whenever a time varying flux links with the aluminum disc, there will be an induced EMF. According to which law? Sir? Whenever a time varying flux links with the aluminum disc, there will be an induced EMF. According to which law, sir? According to Faraday's law. So whenever a time varying flux links with aluminum disc, there will be an induced EMF according to Faraday's law. How do you calculate the induced EMF according to Faraday's law? E is equal to N d phi by dt. Here N is equal to 1 because number of turns. Aluminum disc is treated as one turn coil. Here N is equal to 1 because aluminum disc is treated as one turn coil. As aluminum disc is treated as one turn coil, here N is equal to 1. Okay. Now there are two fluxes, phi1 and phi2. So there will be two induced EMFs. So phi1 is equal to what? Phi m1 sine omega t. Phi m1 sine omega t. So due to this flux phi1, what is the induced EMF? Induced EMF will be E1 is equal to d phi1 by dt. E1 is equal to d by dt of what is phi1? phi m1 sine omega t. Phi m1 sine omega t. That is differentiate, what you get? Phi m1 omega sine omega t differentiation is what? Cos omega t. Phi m1 differentiation is cos omega t. So you got E1 is equal to phi m1 omega cos omega t. Phi m1 omega cos omega t. And what about E2? So you have the second flux phi 2. You have the second flux phi 2. Phi m2 sine of omega t plus phi. Phi m2 sine of omega t plus phi. Due to this phi 2, the induced EMF, induced EMF is E2. E2 is equal to d phi 2 by dt. So d by dt of phi 2 is what? Phi m2 sine of omega t plus phi. So what do you get here? Phi m2 omega cos of omega t plus phi. Okay, this is the value of what? E2. Now observe, here you have two fluxes. This is flux phi 1 and this is the flux phi 2. The phase between these two fluxes is phi. Okay, the induced EMF lags the flux by how much? 90 degrees according to Faraday's law. So induced EMF lags the flux by 90 degrees. So E1 lags the flux by 90 degrees and E2 also lags the flux by 90 degrees. So this phase will be also phi. Okay. Now if you consider, let R be the resistance of the aluminum disc. If R is the resistance of the aluminum disc, so there are induced EMFs. R is the resistance of what? Aluminum disc. Resistance of aluminum disc is capital R. Now you know the EMFs induced E1 as well as E2. So here you have induced EMF E1 and relation and induced EMF E2. So aluminum disc is a closed circuit or open circuit? Closed circuit. So there will be currents driven due to EMF E1 and E2. Okay. So as aluminum disc is a closed circuit, now let R be the resistance of aluminum disc. Let R be the resistance of the aluminum disc. Okay, R is the resistance of what? Aluminum disc. Now due to the induced EMFs E1 and E2, there will be two currents. Okay, as aluminum disc is a closed circuit. Aluminum disc is a closed circuit. As aluminum disc is a closed circuit, there will be two currents. There will be two currents, I1 and I2. I1 and I2. I1 is equal to what? E1 by R. I2 is equal to what? E2 by R. So how do you calculate I1? I1 is equal to E1 value is what? Phi m1 omega cos omega t. Phi m1 omega cos omega t. E2 value is what? Phi m2 omega cos of omega t plus phi. Phi m1 omega cos omega t by R. This is I1. What about I2? I2 is equal to phi m2 omega cos of omega t plus phi by R. Okay. Now, so there are two currents I1 and I2. So there are two fluxes phi 1 and phi 2. Now you have developed the two fluxes. There are two fluxes phi 1 and phi 2. Due to this flux phi 1, there is an induced EMF E1. Due to this flux phi 2, there is an induced EMF E2. Due to E1, there is a current I1. Due to E2, there is a current I2. Now, interaction of flux phi 1 with the current I2 will develop one force. Interaction of flux phi 2 with this current I1 will develop one more force. So the resulting force is the difference of those two forces. Okay. So one force F0 dash is phi 1 into I2 and the other force F0 double dash is phi 2 into I1. Now let us see. So F0 dash is phi 1 into I2. Phi 1 is what? Phi m1 omega, sorry, phi m1 sine omega t, phi m1 sine omega t. And I2 value is what that you have derived here. I2 value is what? Phi m2 omega cos of omega t plus phi by R. Okay, resulting force F0 dash due to this interaction will be what? Phi m1, phi m2 omega by r, phi m1, phi m2, omega by r, sin omega t, cos of omega t plus phi, and the resulting force F naught double dash, that is phi 2 into I1. Phi 2 value is what? Phi 2 value is phi m2 sin of omega t plus phi, and I1 value is what? Phi m1 omega cos omega t by r, So resulting force F naught double dash is interaction of this. What do you get? Phi m1 phi m2 omega by r sin of omega t plus phi cos omega t. Okay, you have got these two forces. One is interaction of flux phi 1 with I2, and the other one is phi 2 with I1. So the resulting force is the difference of these two forces. Okay, now I will show this. Just give me a minute. I will show that. Diagrammatically how it will be appearing. So here. Just wait. Just wait a minute. I'll be showing that. Just a minute, sir. Please be patient. So you can observe this. Just wait. So I think all of you are getting this screen, okay, which is showing the two fluxes. There are two fluxes, phi 1 and other phi 2. Two fluxes, phi 1 and phi 2, linking with the disk. So there will be two induced EMFs, E1 and E2. So there will be two currents circulating, I1 and I2. So one force is F1 and the other force is F2. Here you got two forces, F1 and F2, developed in the disk. I think you are getting this, F1 and F2 in the disk. So these two forces are opposite direction. That's why I have taken the difference. of that. Okay, I think you got the idea about this. Let us go back to our derivation. Now, the resulting force will be what? The difference of these two forces. The resulting force will be the difference of these forces. F naught will be F naught double dash, difference of F naught dash. So what is the same common terms in this? Phi m1, phi m2, omega by r is common. Phi m1, phi m2, omega by r is common. Sin of omega t plus phi, cos omega t, difference of cos of omega t plus phi, sin omega t. This is in the form of what? Sin a cos b minus cos a sin b. That is in the form of sin of a minus b. So if you find the difference of that, so the F naught resulting operating force, what do you get? Phi m1, phi m2, omega by r sin phi, If you simplify this expression, there is sin a cos b minus cos a sin b, sin of a minus b. If you calculate that, you'll get it in the form of sin of phi. Okay, so phi m1, phi m2, omega by r sin phi. Is there any time varying term appearing in this expression? Is there any time varying term appearing in this expression? No. The operating force is not consisting of any time varying quantity. So it is a unidirectional force. There will not be any pulsating force. There will not be any pulsating force, that as we have discussed. Okay. In case of electromagnetic attraction type relays, there you have a pulsating force. Here you have no pulsating force. Unidirectional force is developed. So whatever the disadvantage that electromagnetic attraction type relays are experiencing, that is overcome by using what? Electromagnetic and induction type relays. Okay, by using this electromagnetic induction type relays, that problem has been overcome here. So this omega by r is constant, so you can write operating force is equal to some constant k1 into phi m1 into phi m2 into sin phi. Here k1 is what? Omega by r. This is constant. Okay, this is a constant. How we are developing the restraining force here? How can we develop the restraining force? Any idea how to develop the restraining force? Restraining force is developed by what? A spring. Here also the restraining force, restraining force is developed by what? Is developed by spring. Is developed by spring. Restraining force is developed by spring. How, sir? This is a disc, and to this disc there will be a spindle attached. So to this spindle will be attaching the springs. Here the springs will be used to develop the restraining force. Okay, restraining force is developed by spring, so restraining force developed by the spring, Fr will be constant. For relay operation, what condition must be satisfied? For relay operation, what condition must be satisfied? Operating force should be greater than the restraining force. So for relay operation, what condition must be satisfied? Operating force should be greater than restraining force. When operating force is greater than the restraining force, the relay will operate. Okay. Now let us analyze where you can use this shaded pole type relay. What is the application of this shaded pole type relay? Where to use this shaded pole type relay? Let us analyze. Okay, this shaded pole type relay can be used as an overcurrent relay, or over voltage relay. Shaded pole type relay can be used as an overcurrent relay or over voltage relay. Here operating force F0 is what? Some constant K1 into phi m1 into phi m2 into what? Sin phi. Phi m1 into phi m2 into sin phi. Okay. Let us use phi m1 is equal to phi m2 is equal to some flux phi. Okay. Now operating force is directly proportional to what? Phi m1 into phi m2. Yes or no? Phi m1 into phi m2. So operating force is directly proportional to what? Phi m square. That means operating force is directly proportional to Im square. Yes or no? The Im square. So from this also we can say that operating force is directly proportional to operating quantity square. Even in case of shaded pole type relay, the operating force is directly proportional to what? Operating force is directly proportional to square of the operating quantity. Operating force is directly proportional to square of the operating quantity. So if you want to sense current, it is directly proportional to square of the current. For sensing voltage, F0 is directly proportional to square of the voltage. For current, it will be directly proportional to square of the current. Okay, I have discussed this shaded pole type relay. I will repeat this shaded pole type relay once again. If you have any doubts, you can get cleared. Okay. Now I will start from this induction type relays. Observe here. Listen carefully, sir. I am repeating every topic 3 times. Okay, 3 times you are getting revised. Don't be in a hurry. If you have missed anything, you can revise, and if you have still doubt, you can ask in the doubt session. No problem. Okay. Electromagnetic induction type relays. Okay. They can be used for sensing only AC quantities. They can be used for sensing only AC quantities. They cannot sense DC quantities because induction principle is only for AC. For DC, there will not be any induction. Okay. The basic requirements are what? What are the basic requirements for using this electromagnetic induction type relays? Here, the basic requirements are like this. We require two working fluxes. How many working fluxes are required? Two fluxes. How do you develop those two fluxes? That can be done either by using the split phase technique or quadrature winding mechanism. Split phase technique or quadrature winding mechanism. So these two fluxes must be with certain phase displacement. These two fluxes must be with certain phase displacement. How do you get the phase displacement between the fluxes? The phase displacement between the fluxes in the shaded pole type relay I have shown by using a shading band. And these two fluxes have to be linked with a aluminum cup or aluminum disc. Okay. Now, whenever the two fluxes are linking with the aluminum cup or aluminum disc, there will be an induced EMF. According to which law? Faraday's law. Whenever flux linking with another current will develop the force. Okay. That is the basic explanation. There are three configurations: shaded pole type relay, watt hour type relay, and induction cup type relay. How many configurations are there? Three configurations: shaded pole type relay, watt hour type relay, and induction cup type relay. First one, let us take up shaded pole type relay. There are two fluxes which are obtained by split phase technique in shaded pole type relay. So how we are getting the two fluxes? By split phase technique, splitting the phase. So one flux is obtained by relay coil excitation. Here we are dividing the core into two parts. So we are splitting the two fluxes. And the phase displacement between the two fluxes is obtained by what? How we are getting the phase displacement between the two fluxes? The phase displacement between the two fluxes is obtained by what? A shading band. So the two fluxes are obtained by splitting the core, and the phase displacement between the two fluxes is obtained by shading band. Here shading band means what? Copper coil. Coil will induce lag phase or lead phase, sir. Coil will induce lag phase. Coil will induce what phase? Lag phase. Okay. Now let us consider the mathematical analysis of this. The flux in the shaded portion is phi m1 sin omega t. Flux in the unshaded portion is phi m2 sin of omega t plus phi. This is leading because phi 1 lags the phi 2 because phi 1 is shaded portion. Phi 1 is shaded portion. Okay. So phi is the phase displacement between the two fluxes, phi 1 and phi 2. So whenever a time varying flux links with the aluminum disc, there will be induced EMF according to which law? Faraday's law. E is equal to n d phi by dt. Here n is equal to 1 because aluminum disc is treated as what? One turn coil. Aluminum disc is treated as one turn coil. Okay. So phi 1 induced EMF is E1 d phi 1 by dt. So you get this. Due to phi 2, there will be an induced EMF E2 d phi 2 by dt. So if you differentiate, you will be getting this. Okay. And induced EMF lags the flux by 90 degrees. Okay. Due to these two fluxes, there will be two induced EMFs, and due to these two induced EMFs, there will be two currents because aluminum disc is treated as resistive in nature. Resistive in nature. Let R be the resistance of the aluminum disc here. Due to the two EMFs, there will be two currents, I1 and I2. Now, if you want, I will reshare that slide so you'll be getting a clear idea here. So here, if you observe, two fluxes linking with the disc, two currents are developed. Interaction of flux with current will develop the force, and the interaction of other flux with current will develop the other force. So these two forces that are being developed here, if you apply Fleming's left-hand rule, you will get the direction of force. In machines, you will be learning Fleming's left-hand rule. So you'll be getting the direction of force. Okay. So the resultant force is the difference of those two forces. Okay. The resulting force is the difference of those two forces. Okay, sir. Now, what you got? One force is due to interaction of phi 1 with I2 and the other with phi 2 with I1. Okay. Now, the resulting force is the difference of those two forces. If you calculate the difference, you will get phi m1, phi m2, omega by r sin phi. Omega by r is constant, so we can write k1 phi m1, phi m2 sin phi. Here, how we are developing the restraining force? By using what? Spring. By using spring, we are developing the restraining force. Okay. Fr is equal to constant. So for relay operation, what condition must be satisfied? Operating force should be greater than the restraining force. When operating force is greater than the restraining force, then only the relay will operate. Otherwise, the relay will not operate. Okay. So here it can be used as an overcurrent relay or over voltage relay. Shaded pole type relay can be used as what? Overcurrent relay or over voltage relay. So force is directly proportional to square of the operating quantity, even in case of induction type relays. Okay. Now here, if you observe, the flux in the shaded portion will be more or unshaded portion will be more. The flux in the shaded portion will be less when compared to unshaded portion. This is very important point, sir. The flux in the unshaded portion will be more when compared to shaded portion. The flux in the unshaded portion will be more when compared to what? Shaded portion. The disk will have a rotation from high flux density to low flux density region. The force will be developed such that the disk will move from high flux density region to low flux density region. Which is high flux density region? Unshaded portion is the high flux density region. So the disk will experience force from unshaded portion to shaded portion. Okay. This is all about a shaded pole type relay. This is about what? Shaded pole type relay. Okay. Now let us consider the second one, that is watt hour type relay. This is very important, sir. All of you listen carefully. Watt hour type relay. Watt hour type relay. Okay. That's right. Watt hour type relay. Now let us discuss about this watt hour type relay in detail. Okay. So in case of watt hour type relay, how the two fluxes are obtained? The two fluxes are obtained by using quadrature winding mechanism. In watt hour type relay, two fluxes are obtained by what? Quadrature winding mechanism. Okay. Two fluxes are obtained by quadrature winding mechanism. How the two fluxes are obtained, sir? By quadrature winding mechanism. Here there are two windings in quadrature. Now let us consider this first one. This is upper electromagnet. This one is one winding. This is the second level. So here you have two electromagnets. One is upper electromagnet and the other one is lower electromagnet. Here there are two windings in quadrature. This one is one winding and this one is the second winding. Here there are two windings in quadrature. That is, by using quadrature winding mechanism, we are getting two fluxes here. Okay. Now, as there are two windings, there is a provision of giving two different inputs. One can be excited with PT. It is subjected to what? Voltage. And the other coil can be excited with what? CT. It is subjected to what? Current. So whenever it is excited with PT, it draws the current IV and develops the flux phi V. Whenever it is excited with CT, it draws the current I and develops the flux phi S. Develops the flux phi S. Okay. Here also you got two fluxes, phi V and phi SC. So these two fluxes are to be linked with aluminum disc. These two fluxes are to be linked with what? Aluminum disc. So in between these two cores, there is a provision to place aluminum disc. So here we have placed an aluminum disc. This is what, sir? Aluminum disc. To this aluminum disc, a relay contact will be attached. This relay contact will close the trip circuit. This relay contact, this is nothing but a relay contact. Sir. This relay contact will close the trip circuit. Okay. Now, let us observe the operation of this watt-hour type relay. Here also you have two fluxes. Listen this carefully, sir. This is very important. Here also you have two fluxes. In the previous case, you have phi 1 and phi 2. Instead of phi 1 and phi 2, here you have phi V and phi S. Here also you have two fluxes. They are linking with the aluminum disc. So the same operating force that we have derived in case of shaded pole type relay can be used in case of a watt-hour type relay also. So whatever the expression that we have derived in case of shaded pole type relay can be used in case of watt-hour type relay also. But what is the difference that we will observe here? Okay. Now, here also you can use the shading band. Here also you can use what? Shading band. If at all, if it is required to adjust the phase between V and IV as 90 degrees. Okay. Shading band. Here the shading band can be used if you want to. Shading band means what? What type? What is the nature of shading band? Shading band is a copper coil. So copper coil is highly inductive in nature. Inductive nature means current lags the voltage by how much? 90 degrees. Okay. You can use the shading band. We can use the shading band to adjust phase between V and IV as 90 degrees. If you want to adjust the phase between V and IV as 90 degrees, we can use the shading band. Why 90 degrees? We will see now. Okay. So now if you observe here, with the shading band, let us analyze. So here, this upper electromagnet which I have shown here, this is excited with what? A PT. Here there are two windings in quadrature. So this upper electromagnet is excited with PT. What is the voltage? V is the applied voltage. So here you are using shading band. Shading band is highly inductive nature. So for drawing this, the current lags the voltage by how much? 90 degrees. The current IV lags the voltage by 90 degrees. Okay. Now the flux phi V which is developed due to this IV, will be in phase. Flux and current will be in phase. So the flux phi V will be in phase with IV. Okay. Now observe the second coil which is excited with what? CT. CT is subjected to current means load current. Current lags the voltage. Here let the power factor angle be phi. And flux phi SC will be series flux phi SC which has been developed will be in phase with what? Load current. Okay. Let this angle be some theta. This angle is how much, sir? 90 degrees. This angle is 90 degrees. Okay. Now observe here. So here whatever the force expression that we have derived in case of shaded pole type relay can be used in case of watt-hour type relay. Okay. So the force expression derived in case of shaded pole type relay, can be used in case of whatever relay, in case of whatever relay, in case of whatever relay also. Okay. So here, what is the force expression that we have derived in case of shaded pole type relay? Some constant K1 into phi1, phi m1, some constant K1 into phi m1 into phi m2 into sine of angle between what? Phi 1 comma phi 2. This was the expression that we have derived. Okay. This was the expression that we have derived. Here, if you observe, instead of phi 1, instead of phi m1, you have what? Phi v. Instead of phi m2, you have what? A series flux phi sc. What is the angle between the two fluxes? What is the angle between phi v and phi sc? Theta. So angle between two fluxes phi v comma phi sc is some theta. Now what is the operating force expression that we can write? Some constant k1 into phi v into phi sc into sine of theta. Sine of theta. Now observe this carefully. Here flux phi v is due to what? Flux phi v is due to what excitation? Flux phi v is due to PT excitation or CT excitation? Flux phi v is due to what? PT excitation. Flux phi v is due to PT coil excitation. Flux phi sc is due to what? CT excitation. So we can write phi v directly proportional to V, phi sc directly proportional to I. We can write it or not? Yes or no? Because it is due to PT excitation and it is due to CT excitation. Now the operating force becomes K1 into V into I into sine of theta. V into I into sine of theta. Okay. Now here observe the phasor diagram. How do you write theta in terms of phase angle phi? Theta can be written as 90 minus phi or not? Theta can be written as 90 minus phi. Theta can be written as 90 minus phi or not? Yes, sir. So now the operating force expression, how can we write? F naught is equal to some constant K1 into V into I into sine of 90 minus phi. So operating force expression F naught is equal to, how do you write, sir? K1 VI cos phi. K1 VI cos phi. So this is the operating force expression in case of what? Watt-hour type relay. So what is your observation in this expression? What is your observation in this expression, sir? What is your observation in this expression? Here it is depending on both. It is sensing both magnitude of current. It is sensing both, sir, magnitude of current and phase. It is sensing both magnitude of current as well as what? Phase. As it is sensing both magnitude of current as well as phase, so you can use the watt-hour type relay as a directional relay. You can use watt-hour type relay as what? Directional relay, because it is sensing both magnitude of current and phase. If a relay can sense both magnitude of current and phase, you can use that relay as what? A directional relay. If a relay can sense only the magnitude but not the phase, then it is a non-directional relay. Okay. If the relay senses both magnitude and phase, here phase in terms of what? Voltage and current. Phase is in terms of voltage and current. Okay. If it is sensing both magnitude and phase, so you can use watt-hour relay as what? Directional relay. Understood my point? So as the operating force is depending on both magnitude of current and phase, we can use watt-hour relay as a directional relay. Watt-hour relay as what? Directional relay. Directional relay means it should sense both magnitude as well as phase. Non-directional relay means only sensing the magnitude. Here phase is in terms of voltage and current. Phase between voltage and current. Okay. Now I will repeat this watt-hour type relay again. Watt-hour type relay. Observe here. Here in case of watt-hour type relay, how the two fluxes are obtained? By using quadrature winding. Here if you observe, two windings are in quadrature. Coil axes are in quadrature. So this is upper electromagnet we can say. Electromagnet. This is lower electromagnet. electromagnet, lower electromagnet. This upper electromagnet is excited with PT, lower electromagnet is excited with CT. So here we have got two fluxes by using quadrature winding mechanism. Here you can use shading band if required. Shading band is not always used. I will explain that. If required to adjust the phase between V and IV as 90 degrees, we'll be using you will be using the shading band. We'll be using the shading band because shading band is highly inductive in nature. Okay. So if you are using shading band, the phase between V and IV is how much? 90 degrees. This phase is how much, sir? 90 degrees. So the flux phi V and IV will be in phase. This is series next. Secondary lower electromagnet is excited with CT. It is subjected to current and flux phi SC will be in phase with that. Okay. The force expression that we have derived in shaded pole type relay can be used here also because the mechanism that you are developing two fluxes is different, but the two fluxes are linking with the aluminum disc. The mechanism may be different that you are getting two fluxes, but the operation is same. So what you get here, K1 phi m1 phi m2 sine of angle between two fluxes. This is the operating force expression in case of what? Shaded pole type relay that you have derived. Shaded pole type relay that we have derived. So instead of phi m1 you have phi v here. Instead of phi m2 you have what? Phi sc. Angle between two fluxes phi v comma phi sc is what? Theta. Okay. K1 phi v phi sc sine theta. Phi v is directly proportional to what? Voltage. Phi sc is directly proportional to what? Current. Phi sc is directly proportional to current. Instead of phi v you can write it as V. Instead of phi sc you can write it as I. Angle between two fluxes is what? Theta. This theta can be written as sine of 90 minus phi. So it is cos phi. So here as the operating force is depending on both magnitude of current, it is sensing both magnitude of current and phase. We can use this watt hour relay as what, sir? It can be used as a directional relay. So we can use watt hour relay as what? A directional relay. Whereas shaded pole type relay is a non-directional relay. It is sensing only the magnitude but not the phase. Whereas the watt hour relay is sensing both magnitude as well as direction. So it is used as a directional relay. Okay. I think you have understood about this watt hour type relay and a shaded pole type relay. Okay. Now I will take the doubt session. So if the students are having doubts, you can raise your hands. If you have doubts, you can raise your hands. If you have doubts, you can raise your hands. Kumar.
Yes, sir.
Just a
Hello.
minute. Just a minute, sir.
Okay.
Just a minute. Ask your doubt, sir.
Sir, here in watt hour type relay,
Okay.
shaded band is why we need it, sir.
So here, if required only, that's what I have said. If required only, we will use this shading band is highly inductive nature. This will
Yes,
act
sir.
as load for this coil. This will act as a load for this coil. Load is what? Highly inductive. So the current lags the voltage by how much? 90 degrees. Okay.
Okay, when we require, sir.
That's
Like
what.
require means,
Whenever you want to adjust the phase between V and IV as 90 degrees, we can use the shading band.
why we have to adjust, sir? Is there any
Because
reason?
if you want to get this force expression, VI cos phi.
Okay.
If you want to get this real power force, that is depending on both magnitude of current as well as phase. If you want to get this force expression, you need to adjust that phase between V and IV as 90 degrees. If
Sir,
it is
is
not
the
90 degrees, you will have one more term that we will discuss tomorrow's class.
Sir, phi means power factor.
Yeah, here phi is power factor angle between V and I.
Sir, phi is depends upon load or shaded pole.
It depends on the load, no? Whenever you are saying power factor angle, it depends on the load, no?
Then how the shading bands will?
Shading band will not depend on the load. Shading band is different, no? It is excited with PT. You are operating the system at constant voltage, no?
Yes, sir. But you said that to get phi shading bands.
Yes, no. This one is theta. Angle between two fluxes is what? Theta. So here theta can be written as what? 90 minus phi. Okay. So 90 minus phi is nothing but cos phi.
Sir, in previous class, starting yesterday in
Okay.
open circuit, you said that, sir, in first case 2 may one phase is open,
Hmm.
the electric power is reduced.
Yes.
Sir, as mechanical power is constant, electric power is reduced, means efficiency of the
Electrical
generator
power
is
transfer is reduced.
okay. What about the generated power?
That's what. Whatever the power that you are generating, that must be transferred. No.
Sir, I am thinking. What I'm thinking is that as the generator power is reduced, but mechanical power is constant.
No, 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 no. The power transfer. See here, what happens? Suppose if you think like this, no, that is mechanical aspect. Think like this. If you are driving your bike, okay, with the two
Yes, sir.
persons, you are driving at 60 kilometer per hour. There is no obstacle. You are driving constantly at 60 kilometer per hour. Suddenly, your friend who has sitting in your back seat has jumped down, but your input is same. You have not reduced your acceleration. Your input is same. Then what happens to your bike? Speed increases or decreases?
Okay, in that case, okay, sir. But
Here
what I'm
also the
thinking,
same. What is happening is one of the line is not delivering the power.
why not the remaining lines will carry that current, sir?
That remaining lines will carry the rated power, no, as per their need.
There is no loading effect on the remaining lines.
That's what I am saying. What is the effect of that disconnection of one of the circuit? When one of the circuit is disconnected, what I am saying, the machine will experience what? Acceleration, yes or no?
Yes.
Whenever it is accelerated means the stored kinetic energy. Kinetic energy relation is what? Half I omega square. This stored kinetic energy gets increased. Whatever the excessive power that has been generated, that has not transferred, is in the form of kinetic energy. So omega increases, speed increases, and frequency increases. Ultimately, it is resulting in what? Increase in voltage again.
Sir, my doubt is what is that? You said that,
See,
sir.
if you observe here, the windings will be like this, sir. R phase, Y phase, B phase. This has been opened. These two are delivering the power. Whatever the power that has been generated in the winding, this cannot be transferred, no?
Then the efficiency of the generator is reduced.
Sir, this is a fault condition. At that fault condition, we will not calculate any efficiency.
Why, sir? Output by
This
input.
fault exists only for shorter duration, sir.
Why? So we have to analyze this efficiency, sir, generator.
What I am saying is efficiency is analyzed in the steady state condition, not in a transient condition. Okay.
Okay.
If you want to analyze the efficiency of this machine, that means you are analyzing the efficiency only for two phases. This phase has no importance there.
Okay. Then
Okay.
what will happen, sir?
Ultimately, efficiency decreases. That means if you are constantly operating like this, efficiency decreases. Moreover, we will not operate the system like this because this is an unbalanced system. Okay.
Okay, sir. Sir, another I have doubt, sir.
Okay.
Sir, in inverse time relay, sir, you said, no? In inverse time relay and IDMT relay, the difference is core saturation.
Yeah.
So why we not considered core saturation in inverse time relay, sir? Why we considered core saturation
In
IDMT?
inverse time relay only, that is IDMT is one of the inverse time relay characteristics.
Okay, in inverse time relay there is no core saturation.
That's what I am saying. Yeah, that is operating. Every core will have saturation point. Okay.
Yes, yes.
If the core is not saturating, that point should meet the axis at infinite. Okay, that is an ideal nature. Okay. In inverse type relay, we have different types: very inverse, extreme inverse, and IDMT type relays. Okay. So if you observe time versus current characteristic in case of IDMT relay, at this saturation point, suppose it is going for definite time operation. This is IDMT characteristic. Okay. So we have very inverse relay. Very inverse relay means it will saturate at a later stage. Okay. This is very inverse relay characteristic. And we also have extreme inverse relay characteristic. Extreme inverse relay characteristic will saturate at a further later stage. This is extreme inverse relay. All these are what? Inverse type relay characteristics only. Okay. That depends on the saturation stage.
Sir, One more doubt.
Are you there?
Sir, in PSM,
Hmm.
plug setting multiplier is there, sir?
Hmm.
PSM.
Okay.
Sir, is the PSM is used for increasing the rating of relay? Is that true, sir?
PSM is not using for rating of the relay. What
Means,
is your
for
observe? What
example,
is
if
your
relay is
question? What is your question?
what I am thinking is that actually if CT race is 400/5 is there,
Okay.
if we don't consider any PSM like that,
Hmm.
then with the plug setting of 120%, the relay can operate at 6 amperes.
Okay.
So 6 amperes in secondary means in primary it should be like 80 into 480 amperes. So fault current at 480, the relay operate.
Not like that, sir. Here, if you observe, relay is connected where relay is connected to CT secondary side. Yes or no? Relay is
Yes.
connected to CT secondary side. Okay, by default, relay will be connected to CT secondary side. Here, primary side fault current is how much? 4,800 amperes. So, what is the fault current reflected on secondary side? Suppose here the CT ratio in this question, CT ratio given is 400/5. Fault current reflected on secondary side will be how much? 4,800/400/5. Okay. How much do you get? 5 8s are 40. Okay. This one will get cancelled. 6 8s are. So how much current you are getting here?
There, sir.
60 amperes. Yes or no?
Okay, 60 amperes.
60 amperes approximately. So the fault current which is reflected on relay side is 60 amperes. But here relay is observing, relay pickup value is how much here?
6 amperes.
IPC is how much? 6 amperes. So whenever the current seen by the relay is more than 6 amperes, the relay is expected to operate.
But PSM means it increases the value, na?
PSM is a multiplier, sir. It will not increase any value.
Yes, sir. For example,
If
if the
PSM
relay,
is greater than 1, the relay will operate. If it is less than 1, the relay will not operate.
sir, so actually, what is the need of PSM, sir?
What is the need of PSM is here the characteristic of the relay. If you observe, it will be given in terms of here. If you observe, the characteristic of the relay will be given in terms of PSM and time. For that particular PSM, what is the time of operation will be given. Why? This PSM includes both. This time of operation depends on two factors. No, one is the fault current, because that fault current will decide the speed of rotation of that moving contact, and the second one is the distance that is to be traveled. Okay, so that depends on TSM, the time multiplier setting, total time multiplier setting, and it also depends on the relay setting, how much relay setting you are keeping, that is 120% or 140% or 150%. Based on that, the characteristic has been developed between PSM and time of operation.
Sir, not like that. I want to know in real applications, sir.
This
At
is
what
real
time of
time
application
characteristic only that I have given.
means like.
Suppose if I will show one slide, just wait.
So why we want to use use PS?
So just
sir?
wait.
It is an additional circuit, no?
I am sharing you this. Just wait. So if you observe the, I think you are getting the slide of this, no?
Yes.
Now you are getting or not?
Yes, sir.
So this is the overcurrent relay characteristic. Okay. Oh, sorry, overcurrent relay nameplate rating. Here, if you observe the plug setting multiplier and time in seconds. So this will be the characteristic given by the manufacturer. Okay, understood my point? So again, these are the plug setting points. Suppose if you want to use the relay at 2.5 amperes, you should insert the plug here. If you want to use the relay setting as 3.75, you should insert the plug here like that. Okay.
That's
These
why
are the
I am saying, sir, to increase the rating of relay operated value, PSM is using.
What I am saying, what you are saying?
To increase the operated value of relay, PSM is used like 2.5, 3.75, 10 amps like that. So to operate at that value, PSM.
Sir, we have multiple pickup values, no?
Yes, sir. To increase, like if I want to.
What I am saying is, if you are not using multiplier, if you are not using the relay setting at different points, if you have only one setting, then
yes,
there
sir.
is no use of this multiplier value.
I am asking that, sir. Because of PSM only, we can increase or change the
You can
rate
get
of the
multiple
rating
pickup
of the
values.
relay. Like that.
We can establish the characteristic of that relay for multiple pickup values.
Okay, sir. If I put the PSM like, if you show the animation value, sir, can I show?
Okay.
So if I put PSM like 10, is there?
You cannot put, sir. That PSM depends on fault current also. Only the thing that you can change is relay setting. Only you can change.
PSM also change, sir.
Sir, this is a characteristic data. This is the characteristic data. This is the setting. Okay.
Yes, sir. If I use that 10 amps, so it will operate at in between 2.8 seconds like.
That PSM is not amperes. PSM will not have no. I have given that point. PSM and TSM will not have any units.
Okay.
Amperes will not be there for PSM, sir. It is not a current setting. It is a multiplier. That's all. Okay. Only current setting will be there. Okay. Right. Sriyas.
Sir, good evening, sir.
Good evening.
So, can you share your email ID with us?
Huh?
Can you share your email ID, sir?
Email ID. Yesterday I have shared. I will also.
So the notes were not uploaded, so I couldn't get it. So notes were not uploaded in the net, sir.
Okay. I will share my email ID and my. So just wait. ckr.net@gmail.com. Okay. So you can send it to me if you have any queries, or you can also send it. You can WhatsApp to me.
Okay, sir.
Akshaya Tota.
Yes, sir. Can you hear me?
Yeah.
So, in the selectivity of relay, sir.
Okay.
How do we decide whether it is unit selectivity or non-unit selectivity, sir?
That depends on the type of the relay. Suppose if you are using a differential relay, if you want to protect this electrical equipment, if you are using differential protection, then it will only prescribe its zone of protection to this region only. Okay. Only this zone of protection is used for protection of this. Okay. Beyond this, if any fault takes place, this relay will not sense. So it is a unit selective relay. So based on the application, now listen here. So this is an alternator, and here you have a transformer, and to this transformer HT side, number of lines will be connected in parallel. Okay. Now, if any fault takes place on this line, the fault current will be delivered by this generator to this fault point. Okay. The source is only the generator. Now this fault is observed by the relay of generator, the relay of transformer, the relay of transmission line. Okay. Here we require unit selectivity for transformer protection as well as alternator protection. Understood my point? Okay. Because the fault is not in the zone of alternator and transformer. Here R3 has to operate for the fault. If R2 operates or R1 operates, what happens? This total network loses the supply. That is a security problem. Security means what? It should not operate whenever it is not required to operate, because even it is observing the fault, but it should not operate because the fault is not within the zone. Based on the place where you are using that relay, that will decide whether you should use a unit selective relay or a non-unit selective relay.
So in the example you have given, how did you decide, sir?
I have defined there what do you mean by unit selectivity and non-unit selectivity.
No, sir, you have taken relay 1 and relay 2 and you have given, R2 as unit selective and R1 as...
If there in that problem, what I have said there, here I have taken two sections. This first section is protected by relay R1, second section is protected by relay R2. So if the fault is taking place in this zone, if R2 operates for this fault, that is nothing but unit selectivity because the fault is within the zone of R2. For this fault, if R1 is operating, then it is nothing but a non-unit selective operation.
Okay. So if short circuit is placed in between R1 and R2, then R1 has to be
Now,
considered.
if
Sir.
it is placed in between R1 and R2 means here you are saying location. Huh?
Yes, sir.
That is a bus fault. That is again a different aspect that we will discuss bus bar protection.
Yes, sir. Sir, also I have doubt in
Can you
shaded
speak
pole.
louder?
So in shaded pole type relay, sir, how did you decide the direction, sir? Can you please explain once again?
How do you decide the direction?
Can you please show the 3D figure of the discs, aluminum discs?
Okay. You are getting
Yes, sir.
Here you have two fluxes, no?
Yes, sir.
Two fluxes and two currents. Okay. Apply Fleming's left-hand rule.
Yes, sir. We just know the direction of flux, only flux. How can we, can we decide force and current direction by only knowing flux, sir?
Just wait. What you are getting? What is your doubt here?
So we just know the direction of flux, right?
We know the direction of flux. Once you know the direction of flux, you will know the induced EMF. Once you know the induced EMF, we can place the direction of current. Apply thumb rule, right hand thumb rule you apply.
Okay, sir.
You will know the direction of current. Once you know the direction of current, you apply Fleming left hand rule. You will get the.
Okay, sir. Okay, sir.
Prasad. Vinita. Akash Tumala. Anil Kumar.
Hello, sir.
Ask your doubts.
Sir, in whatever type meter, we are using two coils, sir. One is potential and another is current. Sir, it is used for over current or over voltage or both?
Here, mainly in this discussion, over current protection I am taking up. Over voltage, this directional element not required.
So the operational force is
to use over voltage directly. If you want to use over voltage directly, exert both the coils with the same source. Okay, even in case of over current also, if you want to use only a non-directional relay, then you can exert with the same source. I will discuss that tomorrow.
Okay, sir. Here operating force is depending on current itself.
Current magnitude as well as phase.
Phase magnitude. Okay, sir. Thank you.
Hello.
Ask your notes.
Sir, what is the meaning of Wirth operation, sir?
Wirth means boundary operation.
Boundary means, sir?
Boundary means.
Yeah, elaborate that one, sir.
What do you say? Suppose if you get the characteristic of any element like this, so current versus voltage characteristic, suppose we are getting a characteristic like this, okay? So above this it will operate. This is the operating region, and below this it will not operate, okay? It is not in operation region. So this line is nothing but a boundary value, okay?
Okay, sir.
Understood my point?
Yes, sir.
Suppose if you say your limited speed is 100, if you go 101, it is over speed. Below that, it will be under speed. That will not cross any limitation.
In that case, the relay, what will happen, sir?
That will be operated, no? Once it crosses its set value, it will be operated.
Okay, sir. Another doubt, sir.
Ask your doubt.
Why at generation station, power can be generated multiples of 11, sir?
I'm not getting what you're saying.
Why at generation station
Ah.
power can generated multiples of 11, sir, like 11 kV, 33 kV. What is the reason behind that one, sir?
I have said that generation voltage. I think you are saying about generation voltage levels. Okay.
Yes, sir. Yes, sir.
Generation voltage range is in between 11 kV to 33 kV. 11 kV to 33 kV range. This
Yes,
11 kV and 33 kV is not fixed. In between 11 kV also 33 kV also you can have. Even less than that also they have done 6.6 kV. But generally it is ranging between 6.11 kV to 33 kV. That's what.
Sir, in distribution side also 33 by 11 is there, na, sir?
33 by 11 kV distribution transformer.
Why we want to step down 33 by 11 only, sir?
33 by, I am not getting what you are saying, sir.
Sir, in distribution side, substation, we will consider one substation.
Can you do one thing? Whatever the doubt you have, just send me the email, okay? I will.
Okay, okay, sir.
I'm not getting what you are saying.
Okay, sir.
Mamata. Kushal.
Hello, sir.
Ask your doubt.
Sir, the shaded region in the last whatever type relay, if it is not present, then the voltage and current IV and V are in phase, sir, or some
In
out of
shaded
phase
pole
there.
type relay, what is your doubt?
Sir, if the shaded is not present in there, whatever type relay.
Then what happens if the two fluxes are in phase? No? If the two fluxes are in phase, what is the operating force? Sine 0. Sine 0 is what?
Sine 0, 0.
Sine 0, 0. Will there be any operating force?
No, sir.
That's why we require the phase displacement between two fluxes.
Okay, sir. But there is some phase definitely present there. Some phase.
Why it will?
angle.
Why it will be have phase? There will not be any phase because the same
No.
flux. No.
No, we are using it through PT or CT, so there is some phase angle present.
Where? In a
We are
shaded pole type relay, if you are not using shading band, there will not be any phase between the two fluxes.
Oh, we are using PT, sir. So there is something.
That's what. No,
yes.
for PT current or CT current only, we are getting this flux. Okay, this flux has been splitted. Okay, I will give the analysis like this. So here you have a current of 10 at an angle of 0. Here you have the current of 10 at an angle of 0. Okay. So you are splitting this into two resistors. Okay, R1 and R2. So here suppose 5 amperes or here suppose 6 amperes. Here suppose 4 amperes. Suppose what will be the phase? 0 only, no?
Yeah. Yes, sir.
Because there is no suppose instead of that here you are using inductor and here you are using capacitor, then there will not be the same phase. Okay.
Hey, that's why I'm saying, sir. In CT and PT, we are using a coil. Therefore, there's something
That's
specific
what.
will
No,
be
the
there.
CT or PT current, this one only. CT or PT current is this 10 at an angle 0.
Okay. There is no.
That is being splitted. No, there.
Okay. And sir, one more doubt is about yesterday that in open circuit and short circuit, how the power factor depends, increase or decrease in with that.
That is overall inductive nature of the system or overall capacitive nature of the system. If capacitive nature is dominating the inductive nature, that power factor will be somewhat improved because overall system is highly inductive in nature. Okay.
Okay.
Whenever the capacitive nature increases, power factor will be improved.
Okay, sir. Okay.
Okay. Any other student having doubt?
Sir,
Ask your doubt.
good evening.
Good evening.
Sir, in shaded pole,
I'm not getting your voice,
pole
sir.
relay.
I'm not getting your voice.
Sir, in shaded pole type relay, say,
Can you do one thing? I am not getting your voice, sir. There is a disturbance, sir. Lag is there between your voice and me. Can you text me to that mail? What you wrote down?
Hello, sir.
Yes, sir.
Hello?
Hello.
Ask your doubt. I'm not hearing your voice, sir.
Hello, sir.
Ask your doubt, sir.
Sir, can you say how to practice and prepare which type of textbooks like that? Can you suggest
I will
any
give tomorrow's morning class, okay?
tomorrow's morning class?
Okay.
Yes. Thank you, sir.
Yeah, right. If any student having doubts, you can give me a mail or you can WhatsApp me to this number. I will respond to your queries. Okay. Thank you.